Good morning to all of you. So see, just see in the Slack, I basically shared one CSV file. If you're guys able to see, just go in Slack. I think I shared kchouse.data.csv. Please read this file, all of you. Please first read this file. Uh, First read, okay. All of you, please read this file first. Yeah, Meghna, please read this file. Done, all of you. See this, do one thing. First, drop ID and date from this data. All of you, please do this. Drop ID and date from this data. Actually, I will let you know when we will do the data preparation part why I am dropping this. But just try to drop this ID and date from this data set. Very simple. All of you, please do this. And all of you means all of you. So we will be on the same page. So we are able to do everything on the same time. Okay. So all of you, please delete ID and date from this data set. ID and date, this date. Very good. All of you, please do this and say yes. Very good. All of you done. Very good. Now do one thing. Take price. Like suppose you drop this, no? Let me read again. Give me a minute, guys. So, yeah, see this. After you drop this, your data looks like this. Okay. Do one thing. Make this. My screen is not visible. Okay. Give me a minute. See this? After like dropping ID and date, our data looks like this. Like this is the price and this is the all this data. Okay. Now what we have to do, we have to take y price in y and rest of all in x. So do this. You have to put in y because this is our target price and rest all of feature. So do this all of you please. Rest of all is in x. हो गया इतना तो हो गया होगा all of you done or not? Done. Very good. So after this, like I did here, yeah, I did here. I took in X rest all of, and I took here Y. Okay. Now, so we have the data X and Y. Okay. If you want to split, okay, don't split. We will split in later class. But let's do this. Suppose I have X and Y. Now let's build a neural network for that. Okay. So yesterday class I already discussed on the Friday how can we build a neural network. So before that, let me know whether it is regression problem or classification problem. Then you are only able to build it. So all of you, please let me know. It's a regression or classification. Correct. So this is a regression problem. So now all of you build it. Build a neural network. You can open those file already shared with you on yesterday class. So you can open that file and maybe you can copy with the library and all. But try to build this neural network for this regression problem. All of you, please try. Then I will build, but I believe you guys can build because yesterday class we discussed how we are able to build using Keras and TensorFlow. So take your time, build the one neural network for this data set. So do this very fast. देखो यार किसी को अगर ये जस्ट रिमेम्बर यस्टरडे क्लास में मैंने पूरी फाइल भेजी थी इसकी. सो ऑल आर डूइंग ना. ओके, प्लीज डू. हो गया भाई, हो गया. Is it done, all of you? Hello. Hello guys, I'm waiting. Like it will done. Is it done? No problem with accuracy. Okay, don't worry about accuracy. We will see the accuracy. I'm just talking about whether you build neural network or not, and you started training or not. Nothing else. Uh, okay, great, great. All of you done? Because don't worry about accuracy now. We'll see the accuracy separately. Don't worry about accuracy. Okay, please do this, all of you. See, guys, there is one announcement here. See carefully. I think we will do our training till this week. Okay. Now, in the next week, also we have training from two. So two, three, four, five, then six. Okay. So that 6 May will be our last training day. Okay. So at this day, what we are going to do, we will take three tests, but I will take three tests. Okay, so that three test, like on the Friday, like whole day we'll do only test. So I will do test on Python plus R, then I will do one test on deep learning, one test on machine learning, and one test on all the rest of the syllabus. Okay, there will be four tests. So how will be happen, I will start sharing the test to your mail ID. You guys already send me your email ID, na? So I will give you test to your email ID. Okay, you have to do the test. Send that on the same email ID, like my email ID. Are you getting my point or not? Okay, so that will be on 6th May. So before that, try to do all the things. So yeah, yes. Like this, we have the 3 week training now. So first week completed, second is going on, and then this is the third week. So in third week, yeah, please. Okay, so third week there is no training. I have training till the 6th May, na. कब से शुरू हुई? 8 से शुरू होगी, 9 से? अच्छा, ये मेरे को आइडिया नहीं है. अच्छा, चलो, मुझे पता नहीं है बात. ठीक है, देख लेंगे. ठीक है. और सॉरी, मुझे पता नहीं था तो सॉरी. ओके गाइस, सो अगर ऐसा होगा ना, सपोज यू गाइस हैज टेस्ट टू टिल 2 to 6, करेक्ट? सो वी विल, सो आवर थर्ड वीक ट्रेनिंग विल स्टार्ट फ्रॉम 9th May, करेक्ट? Hello? Yes, na? So that time what we going to do, we will do our test on 13th May. That is okay to all of you? Is it okay to all of you? 13th, okay. Okay. हेलो, हाँ बताओ. Okay, no worry. We'll see this. Don't worry, na? Don't worry. Anyone? All of you did? Say yes, no. How many of you did? Like, I'm not able to understand. Please write in chat how many of you already completed. Because the code is same, no? Just you have to change the one or two, three line. Aditya Kumar done. Very good, Aditya. Anyone else? What's up? Very good. Tanish, very good. Very good. So, what's up, Tanish? Kunal. Good. Kunal. अरे बाप रे. Good. I think this time, like right now, all of you are present, no? Let me take the attendance. I think all of you are there. Abhishek. Good. So, have you completed or not? I think I got some name. Aditya done, Vatsal done, Tanishq done, Kunal, Ariman, Pranay. So these guys, like every time, why only these guys done? Do it little faster. Meghna, done or not? Okay, at least you can write doing now. So I at least let, like I have, okay, you are doing. Suppose you don't write anything, I think maybe you are not able to do this. So at least write doing. I've done anything. Good. No, I'm not talking about you only, Meghna. I'm talking to all of you. No, I'm not only talking to you. Doing, guys, do fast. Take 5 minutes more. Do this. Complete this. Take 5 minutes. Do all of you. Now, guys, अब मैं कर रहा हूँ, ठीक है? You guys are taking lots of time, so let me do this, okay? I gave lots of time to all of you to do this, but some of you are able to do this, no problem. Now let me do this, okay? So just follow me. Let me do this. We can do this. So I already shared this file to all of you, but anyway, let me import this library first. You make x and y. See, first of all, whether you are making a neural network or any network, this is your first task to define whether it's a regression problem or classification problem. Suppose you came to know it's a regression problem, please write this. This is the regression problem. Now let's go check how many data in your data set, how many feature basically. So feature will be the x. Just write x dot shape, x dot shape, and check the feature. So here you can see you are able to get total 18 feature we have. Okay, so we have what, a regression problem and 18 feature we came to know. Okay, let's go ahead. There the library, you can run it. Now see, I'm making a model here. See this, how can we build this? I'm just giving the sequential. I already told you in yesterday class. Yesterday means the Friday class. So we say we have to build a sequential because sequential will take care of that, the sequence of all the network. This is a sequential. Then I add the dense layer. In first layer, I'm getting giving 16 neurons. You can give any. Like then we can tune it because first of all, when we are doing building first time network, we don't know how much actually it's needed. Okay, so we can give any number. So I think okay, let's give to 16 to this. Input dim will be the number of the feature. See, we have number of feature is 18, so that's why I'm giving 18. Activation you can give any, maybe relu, leaky relu, tan h, sigmoid. So I'm giving tan h. You can change it and then you can tune it. Then I'm going for the next network. In next network I'm giving 12 neurons, and again it's a tan h. See, and then I'm giving the 4, and then the final one. Because it's a regression problem, that's why see carefully in the final layer I'm not taking any here activation function. That's a simple task. Let me open the paint here. So basically my network looks like this. My networks looks like this. Just see carefully. Solar neurons in first layer. So total solar. Then we have total bar 12 neurons. So just write 12. And then we have 4 neuron, and these are the final layer. So this is the my neural network. I have total 18 feature here, 18 feature here, and all are connected like this. All are connected like this. So this is my fully connected neural network for a regression problem. See this, because it's a regression problem. That's why there is no non-linearity here. Here in the final layer, I using optimizer as ADA grade. You can give anyone. Don't worry about these parameter. Only give learning rate. But you have to decide. You can take any number and then you can optimize this. So this is our learning technique. Then I am compiling this with mean square error because it's a regression problem. So whenever it's a regression, we can give the regression problem optimizer. You can't give here accuracy because in regression accuracy will define in a something other way. I will discuss that. Don't worry. So see this, and now my network is built. Now if I want to let's call this function, and now I want to run it. So maybe I'm running not like this. I'm running only 2 times because otherwise it take less of time. So maybe I'm running only 2 times through this, and maybe I'm giving 64 number of batch size. So now let's run it. See, it is little slow because one program is also running on my laptop, network program. So maybe due to that, it is little slow. But don't you worry. Okay, guys. So okay, no problem. Run होने दो. But ये बताओ कि why you guys are not able to make it? Where you are facing problem? Because very less people are like able to complete this. So that's why I really want to know where you guys are facing challenge. If you guys let me know, so I can do something for you. Where where you are using SQL? We are using SQL. This process where we are using SQL. Till now we are not using, but Sudhir Yadav, if you want to import it, please install it. Otherwise, you can share your screen. Just share your screen, so I can at least help you. Sudhir, please share your screen. Oh, please. Okay, no issue. Please share your screen. So let me see. How can I help you? थोड़ा इसको बड़ा करो यार. See, just click Control and plus. Just click on Control and plus. From SKLN did pre-processing import one hot encoder, no more develop SKLN. Uh, I think you are using just go like in the upper cell, and here you are doing the pip install C burner. Just write pip install SKLN. Just write here pip install SKLN, and just write here itself in Jupyter Notebook. No problem. No problem. After the cell also you can do. Pip install. Yeah, if you use pip install and give the scalar. Run it. So what is saying? Go to kernel. Just go to kernel. Upper. Restart it. Everything. Just restart it. Now again run it. Run this. Not this install. Not the first cell. Just go and run the first cell. Yeah, run this cell. Still getting the same problem. What is saying? S no module display. Okay. So where you install the Python, just go to Python script. Yeah. Go to the I think your user and then go. Yes, yes, Python script only. Just go in your C. Somewhere user and what is this? Name programs. Actually, I'm not able to see properly your screen. It's very small. Can you click on Control and plus? Yeah, see this. What is the path? What is the path? Yeah, see this is a script here, na? This is a script here, na? Click on the script. What is this? Please read it like. What is? Okay, just copy the path. Just copy the path. Copy the path. Come to your CMD. Write CD. Paste it. Enter. Now are you in script? Now pip install sklearn. That is fine. Just go on netbook. Again do the restart. Kernel restart. Now run that particular. Yeah, run it. Again you are getting the same problem. Now sklearn the models pixel import train test split. Okay. So when you install first time today itself. Okay. So sorry, where you installed? Uh huh. Okay. That time it's not working. Okay. So what is saying? Just saying the S7 module is not there. Correct? Mm-hmm. Okay, I think there is no environment. No, it is almost open, so why it's not happening? Do one thing. Do one thing. For time being, just write on collab, okay, and send me this file so I can check whether there is a problem or not. Okay. So how can you do this? Just upload this file on collab. Do you know how can I upload it? Just upload this file on collab. Okay. Okay. Anyone else other than Sudhir? Anyone else other than Sudhir who is facing the same problem or any other problem to build? Because I have those name who are able to do this. Like very simple, like very less people who completed this. I give a time also to do this, but very less people are able to do this. So if you have challenge, just let me know right now. Otherwise, after very like after 1 hour 2 hour things become little more complex now, because the next in this week what we have to do, what we are going to do, we are going to do little complex thing. Like after 1 hour every time we'll going to more complex. Okay, so if you have a problem, just let me know right now so I can try to explain you. So after that you are able to understand after 1 hour what is going to happen. Okay, let me let me just ask one question. Have all of you completed? Okay, so anyone who is not completed, Kunal, I already know your name. I'm just asking anyone who is not completed. Okay, facing error Atullas. Anyone else? Error means like suppose you are facing error with environment or maybe library. Do one thing, write on collab. Okay, so these things will not happen with you, because if I'm going to solve these error not one by one, our whole day will be disappear in only doing this. So please write it on the collab. Just upload the file. If you have problem on collab, I can do within a minute, because collab is very helpful to do those errors, to solve the error. So okay, Meghna. Okay, very good. So you completed and you put on a stack. Very good. What is your putting in error or maybe error? Okay, great. I will check. I'm just going to check. What is Sudhir is saying? Just a minute. Okay, very good, Sudhir. Very good. Now let me check this flag. Meghna, have you wrote something? You will do. What you write for it? Okay, no problem, no problem, Meghna. You can do. So see this, guys. Don't worry. Again, I am sharing this file to all of you because of this data. I will share the other data. So see, don't worry. See, the whole trying to do everything on collab. Don't try to do on your own machine. Otherwise, suppose we got some problem with environment. Now it will take lots of time, and we are not able to even solve it because environment. Yes, please ask. Yes, yes, I will share. I think some guys ask also, no? Okay, I will. What is manager? I think I made some changes. This should not be. Okay, make that. Please do this. So let me share first this file to all of you. So again this file because I did here. So maybe suppose some of you who like still not completed and maybe he had some hesitation to say he is not completed. So let me share this on Slack, because already always there are some students who are not able to do this, but these guys don't say. That's why I'm trying to help them also. So let me share this file to all of you. Now upload this file again to your collab. Okay, so if you are doing this on collab, how can you see guys, how can I, let me do this. Okay, how can I do this on collab? See carefully, if anyone not able to do this, check it again. But some of you are really good, they are able to do that program within the 10 minutes, and but some of you take almost half an hour not able to do this, and some of even take more time. But there are some students, they are really nice, they are able to do this problem within 10 minutes. See this, see this, just go on upload. Okay, now I'm trying to upload this, so I'm choosing this file, so just choose the file. That is basically DL regression.ipny. I'm just uploading this. See, this is automatically uploaded, correct? This is automatically uploaded. Now let me upload that data also. That is the data. So how can I upload this data? Just copy this data and upload. So maybe your data will be on download or anywhere. Just go there and upload it. I know my data uploaded already in Python file, so I'm directly uploaded from here. I think done. Now if you want to run it, just run it quickly, and I am able to run even faster. See this. Completed. Done. Okay, all of you completed, done, yes, no. Say yes or no. Okay. Now let's check how can we see the accuracy in regression. Okay. See, checking accuracy in regression is not a no, simple way. We can go for a different approach. See, first is remember your loss. So your loss is basically the MSC loss, mean square error loss, and we always try to reduce this loss. So first you can check the accuracy with the MSC loss also. If your loss is very less, you can say my model is very good accurate. But if you are going to check with that, it will, sometimes maybe you will confuse. That's why we have one formula called R square. Called R square. So what is R square? Let me explain you. Actually, see this. I'm making one graph here. Suppose there are some any random point x. For this random pi, maybe y is there. Y. Put at x1, y1. Okay. But suppose you are predicting here. This is yp1. Okay. And maybe the average y is this. Average y means y bar. Okay. This is y bar. See, there is some gap between yp1 and there is some gap between yp1 and y bar. So I can write like yp1 minus y bar. Here there is some gap y1 minus y bar. Here also there is some gap, that is basically y1 minus yp. See, basically, if your model, see carefully, if if always remember this, if this gap y1 minus y bar is greater than y1 minus yp, your model is doing better, because see, uh, we are you are more accurate than Y bar. Y bar is what? Average. Suppose I want to predict the price of maybe the stock price of a Paytm share. Nobody can predict because the share is Paytm share is not doing anyway. Okay, let's go another. Suppose HDFC Bank. You are predicting the share of HDFC Bank. So you are working on that HDFC Bank share. Let me check what is the share price today. Give me a minute. So this is reducing. Right now, HDFC share is 1353. Right now, at HDFC share price is 1353, and it's reducing almost 0.16% का loss है आज HDFC Bank में. Anyway, so suppose you want to build a model. That model is going to predict every day stock price. Okay. Suppose I am an investor of HDFC Bank. Every day I am either investing or selling something. So I am continuously, watching HDFC share for last 1 year. Okay, almost last 1 year. So I know average price will be HDFC Bank maybe between 1300 to 1500. I already know this. This will be happen tomorrow and day after tomorrow also, because I'm every day I'm observing. So even I start I'm observing, so I can predict this amount for the next day. Suppose your model is predicting not better than this, maybe worse than this. It means your model is not good, because average we can predict. Even as a human, we can just try to predict average. Suppose your model is not working better than average, it means your model has no learning. So always remember this: your model has to what? Predict better than average. And the whole R square phenomena is just going around this. Okay, so right now I'm trying to explain this only because there are some important concept needed. Then I will discuss how we are going to build R square formula. So we need correlation, covariance, some statistical topic. So I will discuss after neural network. Then I will let you know how R square will going to build. But still now you have to like little bit understanding of that. Even if your model is not working better than average, that is called no learning in the model. So always remember your model has to be better than the average. So always remember this relation. Using this relation, we are going to build R square formula. So I will this is the formula: y minus y bar whole square, then yp minus y bar whole square. But I will derive that equation. Don't try to write here. I will write that equation. How can we derive this? But before that, I have to discuss some statistical concept, and then I will derive it. Okay. So now we already completed how can build a neural network for regression problem, for classification problem, for binary classification problem, and multiple classification problem. Just today we completed one model that we build for a binary classification problem. Anyone had any problem in it, just let me know. And I believe already I asked this, so you guys are able to do this. Now let's try to build another model for classification problem using neural network. Even I think I don't have that example, so let me, I'll build by me also. But anyway, let me save the data so you guys can also try this. That will be very actually the data on this data. Okay, let me save that data. Google guys, let me first check the data. No, then I will save. So we do the regression. Let's go for a multiple classification neural network. So before, let me check the data, then I will save the data, which data it is, because there are some data which needed lots of cleaning approach. Okay, And you guys are not, maybe you guys are able to do this, but I don't teach, like, till now I didn't teach you, so that's why after the completion of that I will let you know. Okay. Let me check here. It will take a little time. Oh, sorry. How can I check it here? I don't have data here. How can I check it here? Let's check here Excel. Yeah, we can go for this problem. This data set. This data don't need clearing, so let me save this to you. See the data, guys. I shared in your group. Please check it. Guys, are you able to get the data? Okay, very good. So please read that data. Meanwhile, I am also reading the data. See this data, all of you. So no problem with this data. Lots of column here. Okay. So this, you see this data now. There are lots of column in this data. This is the problem with this data. So this, like, phone ID, pixel, density, screen, weight, RAM. processor or something. Just see the columns here. See this so much column in this data. So I want to build a model for rating. Okay. So then my target will be rating. So check the rating of the phone. See this we have a different rating here. Okay. Don't go for rating otherwise data is very less and our columns become lots of columns. So don't go for this. Just try to work for maybe sim1 2G. Check whether this data is containing 2G or not. Yeah. No, don't do this smart. Yeah, you can build. We are doing for a multi-class now. So make for rating only. Make for rating because you are not much interested in that. Basically, the your we are not much interested in what in accuracy. So we can do this because data is very less now. So for such a less amount data, if you have just check the data set. We are able to find it. Data is so high. You know, let's check the data dot set. So we have lots of column here, but very less data. Only 341 data, but column is 88. So it means already data is so mismatched. So we are not able to get good accuracy. But anyway, you can try this. So now let's do this. So your y will be the what? Last one, na? So make it x is equal to data dot I log. Give all the row and column, make it -1. So automatically only the last column is not there. Let's go for y. Just write like this: y is equal to data dot I log. Only give like this. So automatically the last column comes with y. Yeah, this is the last column. So we have y here, and if you want to check the x, see this x. Now if you check the x dot what x dot columns, see this, no rating in this. It means this is the feature. See, not rating is not here. So now I separate about feature and target. So x containing only the data and y containing the target. Okay, now you guys can build the model. Say yes, no. Please do this. Please all of you do this. Now I separated data for all of you. Just what you have to do, you have to go on collab and start building a model. All of you please do little fast. Actually now on Friday I asked you to all of you, please please apply this model or maybe one or two data. But I think some of you do this. Uh-huh. Correct, correct. You can take data from, yes, yes. You can take data from anywhere and we can apply. I knew some of you already do this. Very good. Okay, okay, okay. Very good. Very good. Okay, very good. Very good. Yeah, this is actually the better approach to discuss with your friend. Like right now, they are all of your friends. Now, after 1 month, all of your colleague. So every day you have to discuss. You know. So try to start discussing from today itself. I think someone is like not mute. No? Please be on mute. Vatsal, mute yourself. No, Vatsal, please mute yourself. No problem. No problem. No sorry. Bro. Just hello. अरे क्या हाल है? So you guys completed, very nice. So now see, we are able to, very good, very good. So happy. So all of you are now completed this. How can we build a neural network? We are able to know how can we build a neural network either for a regression problem or maybe classification problem. If it's classification, either binary or multiple classification. If you want to know the bullet point is this: if you are doing with regression problem, in final layer only one neuron, in binary classification final layer one neuron, multiple classification final layer number of neuron is n is the basically the number of class. No non-linearity here in the final layer. Here has to be there, that is sigmoid. For non multiple classification in final layer has to be what? Softmax. You already know this. Loss here is MSC, mean square error. Here binary cross entropy. Here categorical cross entropy. And rest all of are the almost same. So now you all are able to build this. Still you have something left. What? The tuning. How you will tune, how much number of neurons are needed, how much number of layers are needed. Okay, these things are still needed. Tuning, no? So I will discuss. Still we are not able to discuss. We will see this. I will explain you how can we go for an idea, and then slowly we will try to explain it. Okay. So complete. Anyone any doubt in this till now? If have anyone any doubt, just let me know. Otherwise, I will go for a next topic. No doubt. Okay. See, guys, let's do one thing. We just completed neural network using what? Keras and TensorFlow. Now we will see this again, the neural network using only Python. How can we build the network using only Python? So I will explain this, but before that, let's go for a little, a small break, and then after the break, I will try to explain how can build a neural network from scratch. Okay. So because here we are using building neural network through neural network, sorry, Keras and TensorFlow framework. Now let's try to build through a Python only. Okay. So let's go for a small break. So 15-minute break. So there is a 12 p.m. So we will back on 12:15. Okay. So all of you, please come before this time. Then we will start the neural network using Scratch. Okay. Okay, Meghna. Thank you. Thank you to all of you guys. So please come after 15 minutes. Okay. Any doubt? Any doubt? No, no? Okay. So please. Okay. Please go for it. Hello. Hello, guys. Hello. I'm audible. Okay. 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 So let's just start. Let's try to build the neural network using, Python and Scratch. So before that, let me explain it, and then I will going to build it. See carefully how can we do this. Very important. Let me go for a simple network. Suppose I have two feature, F1 and F2, and there are two like one layer, two network, and this is the final layer. Okay. If you check it, it looks like this. Okay. Now you guys already know here there has to be a non-linearity. So what I'm saying H A1 is equal to W naught plus W1 F1 plus W2. Let me. So I'm writing A1 is equal to W naught W1 F1 plus W2 F2. I'm taking W1 this, W2 this, W3 this, W4, W3. This is W naught and this is W naught maybe dash. This is W5, W6, W naught double dash. See carefully. Suppose this is A1. So now here again let me write A2. A2 is equal to W naught dash plus W4 F1, sorry, W, you can say W3 F1 plus W, sorry, W3 F1 plus W4 F2. So this is my A2. A2 is like this, and now H2 is equal to sigmoid of A2, and H1 is equal to sigmoid of A1. So basically what we try to do, this is my A1. A1 is the simple, and then we are passing through a non-linearity. So we already saw in the framework how can we build the equation, and then we passing that equation through a non-linearity. The same here as well. We are building this equation and then passing through a non-linearity. Anyone any doubt in this? Just let me know. All of you are okay with this? Say yes or no. Okay, very good. Now see what happened. Just see the second layer. Actually, the second layer directly not depends on F1 and F2. It depends on H1 and H2. So I'm writing here Y1. Y1 is equal to what? W naught double dash W5 multiply with H1 plus W6, sorry, multiply with H2. And what is prediction? Prediction is nothing but sigmoid of Y1. So this has become a simple neural network where we have some data. We have a data. In that data, we have only two features, F1 and F2. We make the neural network. We building here first equation, passing through this equation through a non-linearity. We got H1 here, then again we are making equation here, and we passing through this non-linearity here, we are getting into H2. So we have H1 and we have H2. Now what we are trying to do, using H1 H2 as an input layer and making this equation, and then we are predicting as a binary classification problem. Suppose so I'm making in the final layer a sigmoid network, and I'm getting the prediction here. Clear or not? All of you clear? See this, there is a problem here. What is the problem? All these weights like W naught dash, W naught double dash, W1, W2, W3, W4, W5, W6. First time First time we select randomly. So basically we are selecting this all this thing randomly. So maybe using this equation we are not able to do a no we are not able to get a good prediction. So it means we have to update this. So if you want to update this, you have to train. We have to do the what? We have to do the gradient. Gradient for what? For all the weights like W naught is equal to W naught minus learning rate, then D loss by dW naught. Then again have to do W1. W1 is equal to W1 minus into learning rate, D loss by dW1, then dw like this. So you have to do for all of this, then we are able to update this. Okay, but the problem here is with network the loss, because you are doing, see, problem is what? Problem is this term. If you are able to see carefully, you are able to understand what is the problem with only this term, this d loss upon dw. Because suppose your dw is 1, dw1. See the network here. W1 is here. Loss will be here. So we have to do the differentiation till this. Okay. So let's see how can we do this. See the network first. Let's try to copy this. See this, all of you. This is the network. Okay. Yeah, this is the network. Suppose I want to calculate a D loss upon dW1. Okay. We already know loss is what? Loss is nothing but 1 upon n summation yp minus y whole square. Y is provided by your client, so don't worry about y. Just try to think about yp. Now let me write here. What is yp? What is yp? Yp is nothing but sigmoid of what? W naught double dash W5 A1, sorry, H1, W6 H2. So this is my YP. But the problem with still here there is not W1, and we are looking for D loss by DW1, but W1 is still not there. So now just break this equation again. So YP is equal to sigmoid. Let me write here. Let me write here. So see carefully. Yp is equal to sigmoid W naught double dash W5. What is H1? H1 is nothing but sigmoid of A1 plus W6, what sigmoid of A2. Let's break it. So Yp is equal to sigmoid of W naught double dash W5. Sigmoid of A1 is what? Here we will get this A1. A1 is like W naught W1 F1 plus W2 F2 plus W26 multiply sigmoid A2. A2 is what? A W naught double dash W3 F1 plus W4 F2. So this is the whole equation. है ना? Now see, just if you write this equation, the loss function, summation yp minus y whole square, then you are able to find this d loss by P W1 because W no one is present here. Say yes or no. Complex, your equation become little complex, your differentiation become little complex. It's not a easy go. Now it's not a easy go. You can directly write a equation, try to do the differentiation and all. Now it will become literally become it become complex. Are you getting my point or not? Say yes or no. Just think just think just think suppose we are building our data for maybe 20 neurons, 30 neurons, 100 neurons, 3 layers, 4 layers, 6 layer. Just think how complex it is if we have to build by our own. Just think how much time it will take, because we have to think how much differentiation and all everything, and it will take lots of time. That's why we are using the framework, because frameworks, why? Frameworks already coded, okay. Matrix are there already, matrix are there, just you have to give the data, matrix activity, and I start working, okay. That's why that is always there, okay. Even, but let's try to build this again. So let's try to build for us. Let me show you one data here. See this data. So we have this target 0, 500, 1, 500. Now see this. So I make it like, if you plot this series, it looks like this. Anyway, so now let's just take it. इसको बोल जाओ, ये एक्चुअली मैंने एक दिन आप लोग के लिए करवाया था, तो इसको भी रखने दो. Now comes here. I'm taking the data. So I'm taking like W naught is basically B1, B1, B2, B3 is 0, and then W1, W2, the same architecture I just show you. I'm making that. So W1, W2, W3, W5, W6, all these take few random values. I'm making one function that is sigmoid. See, I'm making here A1, H1. See, little, in our graph, I think I first take A1, no? And then H1, I believe. See this carefully. I'm taking here like first A1. So A1 is equal to W naught X1, W1 X1 plus W2 X2. X1, X2 are feature, and then W naught, that is B1 basically. Then passing through the sigmoid. Then making A2, H2, A3, H3. If anyone have any problem in this, no, just let me know. Very important. If you are not connecting with this, say yes. Any one of, if one a single person who is not able to connect with these equations, just let me know. Yes. Okay. See this guys, very simple actually. Let me go outside again. Let me see the data. Let's do one by one. See, this is the data. I am taking in x1, x2, and this is my y. But see, So I'm going to do this, but before that, I'm just trying to plot it. So this is a plotting. I'm taking x1, x2, y is a target, converting to numpy array. Okay, let me delete this one because that is not needed. Actually, I did this for you of like, if you remember the third class, in third class I did this. But let me delete this because that is not needed for us right now. Okay, so even if you don't do like this also, see this. So this is our x and y. So just see this. Here we have two features, x1 and x2. Two feature x1 and x2, x1 and x2, and one target, that is what? That is y. And this is a binary problem. If you see this binary problem, now I build this network x1 x2 connected like this. So कितने वेट चाहिए? चार, एक दो तीन चार छः चाहिए, पाँच छः। देखो मैंने छः वेट्स लिए हैं, ठीक है। तीन बायस टर्म चाहिए, एक इसको एक इसको एक इसको। जस्ट सी दिस, आई टुक थ्री बायस टर्म। Got it here till here? Now I make a function for sigmoid, so I make a function here because we are doing through scratch. So I'm just making a function here, sigmoid function. Now see, I'm making this equation. A1 is equal to W naught. W naught here is B1. So B1 plus W1 x1 plus W2 x2. This is A1. Passing through the sigmoid here, non-linearity. So H1 is equal to sigmoid of A1. Then again do for here A2. A2 and H2. H2 is equal to sigmoid of A2. A2 is equal to what? B1, W3x1, W3x1, W4x1, B2. B1 is this, so B1 to B2 is this. Now become H2. Now go for here. B3, W5H1, W6H2. Passing through this. Say yes or no. करेक्ट? इन्होंने पूछा था, अभी किसी ने पूछा था ना, क्लियर आप? ठीक है भाई। हाँ, कोई और किसी को डाउट है? एनीवन? नो, ठीक है। तो ये हमने भाई इक्वेशन बना लिया A1 का और A2 का। अब देखो, तो इसमें कोई बताएगा प्रिडिक्शन कौन सा है एक्चुअली, फाइनल कौन सा है प्रिडिक्शन? YP क्या है मेरा? आप में से कोई बताएगा इसमें YP क्या है? करेक्ट, S3 is YP, वेरी गुड। S3 is YP ना, दिस इज द लास्ट थिंग। आई ऑलरेडी टोल्ड हियर ना, जो इक्वेशन बनेगा उसका जब नॉन लिनियरिटी लेंगे वही जो आएगा वही प्रिडिक्शन है। So this is the prediction. Say yes or no. Clear? तो ये हमारा आ गया prediction. Now let's check whether it's working good or not. So what I'm going to do, I'm take like doing like taking a boundary on point 0.5. If value is greater than point 0.5, I'm saying 1. If value is less than point 0.5, I'm saying 0. So this is I'm just converting into binary. Now I'm plotting it. See, the plot looks like this. Even it's better, but even it's not like better with no because you're doing first times, even it's better. But if you see the real data looks like this. It means 50% variation here, but it looks like 30% red and 70% green. It means definitely lots of opportunity here to train our model, because training is, we can do the training. So we'll do the training, but let's change again the weights, these weights, and let's try to see whether it will give any impact or not. So just let me run again. So now if we change, just we change the weights, we take again randomly. Now we are out of the syllabus. Totally predicting one or zero. Getting my point? Because randomly select कर रहे हैं ना, कभी select किया थोड़ा बढ़िया select हो गया, कभी खराब select हो गया. Right now just see, so lesson is so poor. We are not getting even one binary. All the data is just either zero or one. It means if we change here again, the random weights, we will get another output. See, now this, see, we are getting some, all of you okay with this? Because we are taking random weights, so we don't know whether it's working fine or not. Say yes or no, all of you. Done? Okay, very good. Correct, because the weights are randomly selected. Sometimes little better, sometimes it just worse, sometimes little poor. So that's why happening. No worry, but we will not rely on that. We have to go for training. Let's go for training here. See, I'm running this program 100 times. Okay, I'm running this program 100 times. First, I build this equation. Okay, again A1, H1, A2, H2, A3, H3. Now I'm doing the gradient for all the weights. Like I'm just calculating the differentiation of all the weights, DW, DW6, DB3, then DW1, DW2, DB1, then DW3, DW4. Like I'm calculating differentiation for all these weights one by one, and then I'm, after that doing the differentiation, I'm updating the weights. The same we do in gradient descent. If you remember, the problem like that, here we have a different weights, different labels here. In the first I think the first class or second class, when I discussed that time what happened, just W is equal to W minus learning rate d loss by dw. But here, the story are changed, the syllabus is changed, because we are not doing like this. Totally a different syllabus. Weights are different, layers are different. In each layer, different neurons. But in simple gradient descent, when I was teaching, only one layer, only one neuron on one layer, only like this. Simple one thing is there. So if simple one thing is there, definitely things become little easy. That time, just a simple equation. W is yp is equal to W naught plus W1 feature 1 plus W2 feature 2. Loss is very simple. Summation 1 upon n yp minus a whole square, just like this. Very simple. And we have to do this in d loss upon dw naught, d loss by dw1. Just this. So simple. The story is so simple. Very simple actually. Clear, all of you? Okay. So see, I am doing differentiation here for all the weights. See carefully. for DW5, then DW56, then DDB3, and then uploading the gradient. So now let's run this program maybe for 300 times. Let's see this. Now let's run it. So this is completed. Now let's see the weights here. So these are the weights here. Like after this program, these are the weights like this, and all. Now let's check again. Let's go for again the forward propagation. Again try to using these weights. Now using this weight I am doing this. Now let's predict this. Now see, almost we are predicting 50%. Yes, see, I'm using label is Y prediction. Using Y prediction, I'm predicting almost. See, whether you are learning through the either you are learning doing through your building your neural network using Keras and TensorFlow and all, or maybe you are building through simply Python. Both will give the same result end of the day. The problem with the simple, Hmm. So if you are building with simple, so usually you can do this if you are building with simple way, but if not, it will take lots of time, lots of energy if you are doing with Python because everything you have to build to a scratch. That's why generally we don't try to do this. We directly go for a framework and we try to explain it. Okay, done. Anyone any problem in it? Got the problem why we are generally not doing this using scratch? Say yes or no. That's why this is the problem with scratch because see here very simple network but still we have to write such number of program, and if your network become little complex like till now we didn't make a complex network. Now we are going for that because we're going to take the complex data, so we have to build a very complex network. That time situation just become very lengthy. If you try to write your program, it will take lots of time. That's why generally avoid this. Okay, now let's come again to the neural network. Let's do problem with neural network. I'm going to explain one by one. See carefully. First let's talk about the regularization और penalty. हमने ऑलरेडी इसके बारे में डिस्कशन किया था. Now let's talk more about this. If you remember, I told you general regularization is a two type, L1 or L2 regularization. Correct? See, here in neural network, one regularization called dropout. Dropout. Dropout is really very important. See, how can we do this? Suppose you are building one network, maybe like this. Maybe they are the feature F1, F2. First, all of you let me know why we use regularization. Any one of you? Why we are using regularization? Sorry? Restriction. Why we are using restriction? Correct. If our model is not underfit में तो हम और ट्रेनिंग बढ़ाएंगे. If our model is overfit, okay, what's up? If our model is overfit, we want to avoid the overfit. So if you want to avoid the overfit, we definitely you have to do some approach, some penalty, some methods. So those are regulation. Basically, generally we use regulation. Regulation generally two types. One is called L1 regulation. Guys, I'm coming in 2 minutes. Just a minute, I'm coming in 1 minute. हाँ, so देखो एक बार फिर से. So see, so basically the regularization. So regularization we do whenever there is a overfit in our model. Overfit in our model. So, so in neural network generally we apply dropout here. Okay. So let me discuss what is dropout. See carefully. Dropout means suppose you are doing the training, you are going forward propagation, then you are doing the gradient backwardly. It's called backward देखो जो तुम gradient चला रहे हो उसको backward back propagation भी बोलते हैं. So if you are doing back propagation, okay, we can use dropout. Dropout means when you are doing the forward as well, we can drop some. Suppose you are writing dropout is equal to 20%, and there are suppose 10 neurons. So 10 means 2 will be drop automatically. 2 will drop, but the drop happen what? Randomly. Any two neurons will drop automatically whenever doing the training. So suppose you run 100 times. So 100 times what happen? Automatically every time two neuron will disappear. Suppose here you write again 30%, so suppose it's a 10, so 3 will automatically disappear. So what happened? We are giving some penalty now to training. Say yes or no. This is one type of penalty ना because सिंपली तो ये वर्क नहीं हो सकता ना, तो एक तरह से पेनल्टी हो गई. दिस इज कॉल्ड रेगुलाइजेशन and we will use a lot. We will, even our syllabus also will use this a lot. Okay, clear? So generally in neural network for drop for penalty we use dropout. Got it or not? Only वर्क को समझ में आया, बाकी लोग समझ में नहीं आया. Let me do this again. Okay. See, suppose I have three network here and one network here. Maybe this F1 and देखो, यहाँ पे 3 न्यूरॉन है। सपोज आई एम सेइंग कि मैं 33% ड्रॉप आउट करूंगा। इंटेंसिव 33 लिखा है कि एक ड्रॉप आउट हो हर बार। अब होगा क्या, जब ट्रेनिंग शुरू हुई पहली बार, तो जब 100 बार तुमने इसको चलाया, जब पहली बार चला तो ऐसे होगा कि हो सकता है रैंडमली ये वाला नेटवर्क हो ही ना, मतलब आपका न्यूरल नेटवर्क सिर्फ अब इतना बन गया, इतना। ठीक है। जब दूसरी ट्रेनिंग हुई, दूसरी बार लूप चला, तो हो सकता है ऐसा हो जाए कि आपका ये वाला गायब हो जाए। नाउ योर न्यूरल नेटवर्क इज लाइक दिस। ये नहीं है उसमें। अगली बार हो सकता है ये गायब हो जाए। तो ईच टाइम वन नेटवर्क, वन न्यूरॉन्स ऑटोमेटिकली डिसअपियर। सो उसकी ट्रेनिंग जो होगी वो 100 टाइम्स नहीं होगी, मतलब 100 टाइम्स एक्चुअली किसी की भी ट्रेनिंग नहीं हो पाएगी, कोई ना कोई हर बार हटता रहेगा। हो सकता है किसी की 50 बार हो, किसी की 40 बार हो। तो जो ट्रेनिंग अधिक हो रही है इसलिए तो मॉडल में प्रॉब्लम हो रहा है, ओवरफिट हो रहा है। तो वो इंटेंस जो ट्रेनिंग है उसी को हटाने के लिए ड्रॉपआउट यूज कर रहे हैं कि हर बार एक नेटवर्क, एक न्यूरॉन कम ट्रेन हो। अरे मान क्लियर। तो अभी तक मुझे समझ में आया, 2 लोग क्लियर हो पाया है, वत्सल को और आर्यमान को। बाकी लोग, शिवम, तनीषा से, ओके सभी क्लियर। ठीक है, गुड, गुड मेघना। ठीक है। स्टिल इफ एनीवन thinking not clear, you can ask. Okay, we are going to introduce all these things, don't worry. Now see carefully, I'm going to introduce one very very important concept. See this. See, suppose you are working on a classification problem. You are working on a classification problem. ठीक है। आपने 100 डेटा पे प्रोडिक्शन लगाया, और फॉर्चुनेटली वी ऑलरेडी नो इसका ट्रू वैल्यू क्या है। तो ट्रू में ये था कि मे बी 60 जो था वो कैट थे, और जो 40 था वो डॉग था। जस्ट आई एम सेइंग, एंड यू बिल्ड द क्लासिफिकेशन मॉडल ऑन दैट। सो ओके, और प्रोडिक्शन में क्या निकल के आया? प्रोडिक्शन में निकल के आया मे बी 45 कैट एंड 55 डॉग। ठीक है। रियलिटी में ये है, प्रोडिक्शन में ये है। पता एक्यूरेसी क्या होती है? एक्यूरेसी मतलब होता है करेक्ट डिवाइड बाई टोटल। इट्स अ वेरी सिंपल एक्यूरेसी ऑफ क्लासिफिकेशन। सी दिस, जरा काउंट करो कितना करेक्ट होगा। 45 कैट बताया, 60 कैट था, 40 डॉग था, 55 डॉग बता दिया। इसका मतलब बहुत मिसपैच है। तो हमें नहीं पता कौन करेक्ट हो रहा होगा। एक्चुअल में होता है जितना करेक्ट है डिवाइड बाई टोटल, टोटल तो 100 है, मान लो 30 करेक्ट होगा, तो 30% एक्यूरेसी होगी। विल सी दैट हाउ मच करेक्ट और नॉट, हाउ डू यू नो दिस? सो लेट मी गो इनटू मोर डीपर पार्ट एंड देन आई विल ट्राई टू एक्सप्लेन यू। देखिए सभी लोग, मान लीजिए मैं यहाँ पर रियल लिखता हूँ बाई, और ये मेरा प्रोडिक्शन है। सपोज इट लुक्स लाइक दिस, 0 0 1 1 1 0 1 0 0 1, and suppose my prediction looks like this, 0 0 1 1 0 1 1 0. Suppose this is my prediction. If I want to check the accuracy, so let's see how many times it's correct or not. See, this is correct, 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 not correct, not correct, not correct, correct, not correct, not correct. Just count the correct one. एक दो तीन चार पाँच, डिवाइड बाई टोटल, एक दो तीन चार पाँच छः सात आठ नौ दस दस. So accuracy of this model is 50%. Got it? ठीक है. अभी मतलब ये काफ़ी बड़ा इसके अंदर कंसेप्ट है. मैं धीरे धीरे एक्सप्लेन करने की कोशिश कर रहा हूँ कि आप लोगों तक पहुँचे एक्चुअल में. तो स्टोरी काफ़ी कठिन है, इतना आसान नहीं है. देखो ध्यान से. जनरली इन बाइनरी क्लासिफिकेशन, वन को बोलते हैं पॉजिटिव और जीरो को बोलते हैं नेगेटिव. ओके. मैं ना अभी धीरे धीरे लिख रहा हूँ, आप बस ध्यान से देखते रहना. ठीक है. देखो ध्यान से. देखो देखो वन ये प्रेडिक्शन है और ये ट्रू वैल्यू है. देखो जो वन आया है, आया तो पॉजिटिव है, लेकिन ये सही नहीं है. आना चाहिए था जीरो ना. यहाँ पे बोलना है आपको, हाँ या ना. यहाँ पे जीरो आना चाहिए था ना, लेकिन आ गया पॉजिटिव, तो इसको बोलेंगे फॉल्स पॉजिटिव. यहाँ देखिए जीरो आना चाहिए, जीरो आया, ट्रू नेगेटिव. वन आना चाहिए था, वन आया, ट्रू पॉजिटिव. जीरो आना चाहिए, जीरो आया, ट्रू नेगेटिव. जीरो आना चाहिए, वन आना चाहिए, जीरो आ गया, मतलब फॉल्स नेगेटिव. नेगेटिव जो है वो फॉल्स है. ट्रू पॉजिटिव, ट्रू पॉजिटिव, फॉल्स नेगेटिव. क्या आप लोगों को टर्म समझ में आया? ट्रू नेगेटिव क्या है, ट्रू पॉजिटिव क्या है, फॉल्स नेगेटिव क्या है, फॉल्स पॉजिटिव. एनी वन फॉल्स पॉजिटिव, बिल्कुल फॉल्स पॉजिटिव होगा लास्ट वाला. एनी वन. ध्यान से देखिए. किसी को दिक्कत है इसमें? देखो अगर दिक्कत हो तो बोल दो, क्योंकि ना अब अगला एक घंटा इसी पे बात पे रहेगा, बनता रहेगा. तो अगर दिक्कत, हाँ वन है, इसीलिए फॉल्स पॉजिटिव है. लेकिन जीरो है ना यहाँ तो. आना तो आना तो जीरो चाहिए था ना भाई. गलत आया ना. एक सेकंड. ठीक है। अब देखो मैं थोड़ा सा और इसको आगे ले चलता हूँ। देखो एक मैट्रिक्स होता है, उसको बोलते हैं कन्फ्यूजन मैट्रिक्स। कंफ्यूजन मैट्रिक्स ये क्या होता है? ऐसे होता है। इसको बोलते हैं ट्रू निगेटिव। इसमें डालना होता है ट्रू निगेटिव कितना आया, फॉल्स पॉजिटिव, ट्रू पॉजिटिव, फॉल्स निगेटिव। ठीक है। यहाँ पे लिखा है जीरो, यहाँ पे लिखा है वन, यहाँ पे लिखा है जीरो, यहाँ पे लिखा है वन। ये होता है ट्रू वैल्यू और ये होता है प्रिडिक्शन। ठीक है। ट्रू वैल्यू का मतलब जब जीरो और वन हो, देखो यहाँ पे जब जीरो चाहिए और जीरो प्रिडिक्शन में हो, वही तो ट्रू निगेटिव है कि नहीं? और अगर जीरो चाहिए और आपको वन मिल रहा हो प्रिडिक्शन में, इसका मतलब वन गलत आया, पॉजिटिव गलत, इसलिए फॉल्स पॉजिटिव है। कहाँ पे? करेक्ट, या दिस इज करेक्ट, सॉरी सॉरी, दिस वन इज रॉन्ग, दिस इज रॉन्ग, बिल्कुल बिल्कुल ये रॉन्ग है। ठीक है, दिस इज ट्रू पॉजिटिव, बिल्कुल यार, सॉरी। देखो देखो ध्यान से। तो ये तो नोन हो गया सभी लोगों कि अगर जैसे यहाँ पे वन है, रियल वैल्यू वन है, प्रिडिक्शन आ रहा है जीरो, इसका मतलब जीरो आ रहा है वो गलत है, इसका मतलब फॉल्स नेगेटिव है। ऐसे रियल वैल्यू वन है और प्रिडिक्शन आ भी रहा वन है, तो ये ट्रू पॉजिटिव है। एनीवन, एनी डाउट? इस कंफ्यूजन मैट्रिक्स में किसी को डाउट है? बोलिए। एनीवन? नो? नाउ लेट मी राइट हियर, ओके, एंड यू हैव टू fill the confusion matrix, all of you. I am writing here, see carefully. देखो ये मैं दो जगह लिख रहा हूँ, थोड़ा बड़ा हो डेटा इसलिए, फिर तीन जगह लिख रहा हूँ। ठीक है, ध्यान देना इस बात पे। तो आपको तीनों जगह से डेटा लेना है। ये y है और ये yp है, ये y है और ये yp है, ये y है और ये yp। जरा इन तीनों को यूज करके बनाइए कंफ्यूजन मैट्रिक्स, ऑल ऑफ यू। देन आई विल आस्क कि किसने बनाया है, नाम लेकर के, तो आप बनाइए जरा फटाक से। एक ही में, तीनों का मिला के एक ही में। अब मैं डेटा इसके नीचे नहीं लिख पाता ना, इसलिए मैंने तीन लिख दिया। Done. Very good. All of you guys, please help me to meet this this matrix. Was I'm saying 0, 1, 0, 1. How much you are getting here, guys? Say, speak, please. Hello. 5. Okay. What is this value? And here, all of you are getting same. Say yes, no. Okay. So, what is the accuracy is? Accuracy is basically true positive plus true negative divided by total. So, true positive is what? 5. True negative is what? 6. Total is 5 plus 6 plus 5 plus 6. It become 11 divide by 50% accuracy. Okay. Okay. वेरी गुड. अब देखो थोड़ा और आगे बढ़ते हैं, इस स्टोरी को और आगे बढ़ाते हैं. Suppose there are two model, maybe one built by Harshit and second maybe built by Tanishq. Okay. So there are two model, one built by Harshit and second maybe built by Tanishq. See this Tanishq na this was okay na. See, so built by Tanishq. Okay. Maybe here in Harshit model we are getting 95% accuracy. Maybe in Tanishq model we are getting 84% accuracy. Okay. So just watching this accuracy, we can generally say, yeah, Harshit model is better. Yeah, just see this and we can say Harshit model is better, Tanishq model is not better. We just compare it. But generally we don't do like this. We first try to see the confusion matrix, not only the overall accuracy. Why it is? Very soon you are able to understand this. So let me again make both model. Maybe I am making first Harshit model and second Tanishq model. See carefully. This is Harshit model, okay? And this is Tanishq model, okay? Suppose I am getting like this 90, 0, 1, 0, 1, 1, 8, 2. This is the maybe Harshit model, and this is Tanishq model. 74, 16, 9 और 1. जस्ट कैलकुलेट एक्यूरेसी हियर, क्या आएगा यहाँ पे एक्यूरेसी बताओ कैलकुलेट करके, और यहाँ एक्यूरेसी क्या है कैलकुलेट करके बताइए. दिस इज तनिष्क मॉडल एंड दिस इज हर्षित मॉडल. जस्ट कैलकुलेट प्रोबेबिलिटी एंड सॉरी एक्यूरेसी एंड बताइए फटाक से क्या आएगा. 91%. 91%. चलो इसको मैं जीरो कर देता हूँ, ठीक है, तो कैलकुलेशन थोड़ा इजी हो जाएगा, है ना. अब बताइए. 92 और 83%. विच मॉडल इज बेटर? फर्स्ट वन हर्षित मॉडल. अब देखिए यहाँ पे डाउट आप लोग, देखो हर्षित का मॉडल आपने बोला बेटर है. यहाँ पे देखो ये मॉडल जो है ना, हाँ सेकेंड में ठीक है. देखो ये मॉडल जो है इसमें क्या हो रहा है, ये वन को सिर्फ 2 बार सही बोल रहा है. 20% करेक्ट है ये मॉडल इसके केस में. इस केस में 90%, इसके केस में, इसके केस सिर्फ 20%. यहाँ देखो एटलीस्ट इसके केस में भी, मतलब ये 90% 100% था इसके केस में. इसके केस में 74/90, मान लो ये 82% के आसपास. बट यहाँ भी एटलीस्ट ये 90% एक्यूरेट है. तो ये मॉडल दोनों के लिए वर्क कर रहा है. ओवरऑल वी विल गेट 83% ओके, बट हियर इट्स वर्किंग फॉर बोथ. But this model is only working for this one. This model is even worst model. इसको कभी कोई यूज भी नहीं करेगा इस मॉडल में. Let me tell you some example. Suppose I am asking कल बारिश होगा या नहीं होगा, तो उन्होंने कहा हाँ होगा. तो बोला परसों होगा, नहीं बोला हाँ होगा. So if you say every time yes, at least you will get 20% accuracy. अगर बरसात का मौसम है और मैं निकाल रहा हूँ प्रेडिक्शन कल बारिश होगा या नहीं होगा, और तुम रोज सही बोलो, तो 100 में से 20 बार तो सही हो ही जाएगा 20 दिन, है कि नहीं. सही है सुनो. इसका मतलब विदाउट मॉडल इवन यू आर गेटिंग 20% एक्यूरेसी. दैट्स व्हाई दिस मॉडल इज नॉट ओके. बट व्हाट हैपन, सम guys 1 minute, I'm getting. See this guy. So let me give you some very important examples. Then you will come to know about this particular comparison. Okay. So let me give you one example. Suppose you are working as a data scientist and you are working on a medical data. सपोज 200 पेशेंट आते हैं, मान लो 100 जो है वो कैंसर से इम्पैक्टेड हैं और 100 जो है वो कैंसर से इम्पैक्टेड नहीं है, नो कैंसर. बट सपोज इन प्रिडिक्शन आपने जो कैंसर का इम्पैक्टेड था उसको बोला नो कैंसर, और जो नो कैंसर वाला है उसको बोला कैंसर, है ना. एक बंदे को बात करते हैं, एक एग्जांपल लेते हैं. एक जिसको कैंसर था उसको आपने प्रिडिक्शन में बोला नो कैंसर, और जिसको नो कैंसर था उसको बोला कैंसर. ये बताओ दोनों तो गलत है ना, दोनों गलत है ना, सही तो कोई नहीं है, हाँ या ना. दोनों गलत है. बट दोनों रॉन्ग है. बट दोनों में ज्यादा रॉन्ग कौन सा है, ज्यादा खतरनाक क्या है? वट इज द मोर वर्स? फर्स्ट वन, बिल्कुल. Because if someone is, someone is like impacted by cancer, and if we say no cancer, so वो तो बिल्कुल आराम से घर बैठ जाएगा. और अगर एक महीना बाद उसको पता चला कि मुझे कैंसर है, तो एक महीना में तो काफ़ी, नो, अगर सीरियस इशू है तो एक महीना में तो काफ़ी चीज़ें हाथ से निकल जाती हैं. बट जिसको नो कैंसर है, आपने उसको बोल दिया कैंसर, तो एटलीस्ट वो जाएगा और अपने डॉक्टर को चेक करेगा. देन ही केम टू नो कि इसको कैंसर नहीं था, आपने बता दिया था. नाउ विल बिकम वेरी हैप्पी. कुछ दिनों के लिए आपने उसको थोड़ा परेशान कर दिया. बट यहाँ पे आप जो है, यहाँ पे अगर आप बात करोगे, यहाँ पे आपने एकदम उसके हेल्थ के साथ क्या कर दिया, मजाक कर दिया. अल्टीमेट पॉइंट. सो इसलिए ऐसे केसेस में जहाँ पे कोई एक चीज़ बहुत इंपॉर्टेंट है, हम उसकी एक्यूरेसी पर ध्यान देते हैं दूसरे की अपेक्षाकृत. जैसे अभी आपने ओवरऑल एक्यूरेसी देखा, बट समटाइम्स यू आर गिविंग मोर अटेंशन टू मे बी वन पर्टिकुलर क्लास. Okay, we'll see that how can we do this, but okay, no problem. Let me give you another example. Suppose you are working as a fraud detection. This is another type of data science work. जहाँ in bank especially हम fraud detect करते हैं कि someone is a fraud or not. If someone is fraud, we will not going to give in maybe credit card or loan or anything. Suppose there is a person who is fraud, and second one is no fraud. This is fraud. Suppose you are doing prediction and the like person who is fraud, your model is saying no fraud. Someone is no fraud, your model is saying fraud. Which is more bad? Both are like wrong, but it is more wrong. First one. Why? Okay. Correct. Suppose someone is fraud and you are saying no fraud. So we will give him loan, and then after loan he will disappear. सो आपका पैसा भी गया और कस्टमर भी गया. सपोज समवन इज नो फ्रॉड, गलती से आपने बोल दिया फ्रॉड, तो यहाँ पर आप एक कस्टमर ही आपसे जाता है हाथ से, वो भी क्या पता वो लोन लेगा कि नहीं लेगा, पता नहीं. लेकिन जो एक्चुअली में फ्रॉड हो, अगर आप उसको नो फ्रॉड बोल दोगे तो काफ़ी दिक्कत हो जाएगा. ठीक है. ठीक है गाइज, डन. एनी डाउट इन दिस? आई बिलीव नाउ यू गाइज आर क्लियर विद दिस. करेक्ट. बट जनरली पता है क्या होता है, एक यहाँ पे बड़ी प्रॉब्लम है. प्रॉब्लम क्या होता है ना, ऐसा डेटा जब भी होता है, वेन एवर वी गॉट दिस डेटा ना, एक्चुअली देर इज अ प्रॉब्लम इन इट. सपोज जरा सोचो, इफ यू स्टार्ट गेटिंग सैम्पलिंग, अब मैं भी कलेक्टिंग द डेटा, आई एम नॉट यूजिंग वर्ड सैम्पलिंग, आई एम यूजिंग कलेक्टिंग, क्योंकि अभी हमने पढ़ाया नहीं है. Suppose you are doing collecting, so suppose you are doing collection, you are collecting the data, collecting the data. अब सोचो you go in a specific district, maybe you will go into one district called Noida. Suppose you reached here and start taking sample of like lots of people. अब बताओ तुमने अगर 2000 सैंपल लिया तो कितने लोगों को कैंसर हुआ होगा? सोचो जरा, एक गेस बताओ. गेस, टेक एनी रैंडम गेस. नहीं पागल, 100 होगा, सोचो जरा क्या बात कर रहा है। अगर 2000 में 100 होगा तो 20,000 में कितना होगा? 1000 हो जाएगा। तो है ना? तो 2 लाख में फिर कितने लोग हो जाएगा? 10,000 लोगों को हो जाएगा कैंसर। फिर 2 करोड़ में 1 लाख हो जाएगा। 100 करोड़ में 10 लाख हो जाएगा ना, ज्यादा हो जाएगा। सोचो कितना ज्यादा तुमने कैंसर के पेशेंट बना दिए इंडिया में, है ना? ऐसे नहीं। तो रेंडम केस मारो, इससे तुम सोचो जरा कि 2000 लोग हैं, तो हो सकता है 2-3 लोगों को निकले, या फिर एक का भी नहीं निकल सकता। मान लो 2 लोगों को निकलेगा जनरली। तो प्रॉब्लम इस डेटा के साथ, मान लो तुमने 10,000 डेटा लिया या 20,000 डेटा लिया, तो तुमने पता चलेगा 20,000 में 18,000 लोग जो है वो नो कैंसर वाले हो गए। 18,000 लोग नो कैंसर वाले हो गए। अभी भी ज्यादा ही बता रहा हूँ, इतना ही पॉसिबल नहीं है। 18,000 में भी ले लो, 18,980 ले लो, ठीक है? 18,000 ऐसे लो, 19,800 ले लो ऐसे। चलो, मानो तुमने 20,000 डेटा लिया, तो हो सकता है ऐसा हो कि 19,900 लोग नो कैंसर वाले थे और 100 वाले लोग कैंसर वाले थे। और वो भी तब जब तुम हॉस्पिटल में लोगे। हॉस्पिटल का डेटा बता दो, सैंपल। जनरल सैंपल होगा तो हो सकता है 20,000 में एक मिले, समझ लो, 20,000 में एक मिले, समझ लो। Talking about hospital data, so just go in the random any hospital, start taking the collecting the blood. So maybe you are getting like this in 19,900 जो लोग नो कैंसर वाले मिले और 100 मिले कैंसर वाले। और प्रॉब्लम क्या है ना, इस मॉडल को अगर तुम ट्रेन करोगे क्लासिफिकेशन मॉडल से, जनरल मॉडल से, तो एक प्रॉब्लम जनरेट होगी। वो क्या प्रॉब्लम होगी सोचो जरा। एक्चुअली प्रॉब्लम ये होगी कि वो तो ओवरऑल एक्यूरेसी से मॉडल ट्रेन करेगा। वो हो जाएगा तुम्हारा ट्रू निगेटिव प्लस ट्रू पॉजिटिव डिवाइड बाई टोटल। हो सकता है तुम्हारा मॉडल 99% एक्यूरेट हो जाए, लेकिन फिर भी तुम्हारा मॉडल एक भी कैंसर का प्रोटेक्शन ही नहीं कर रहा है सही में। क्योंकि देखो 19,900 का मतलब क्या हुआ, देखो ध्यान से। 19,900 का मतलब है टोटल हमारे पास 20,000 है। अगर टोटल 20,000 है, अब मान लो 19,900 था ना, में भी 18,950 ये सही हो जाए, तो ये कितना बचा? 19,000 में से 18,950 इधर चला गया, और हमने कितना डेटा लिया था? 19,800 ना। तो जो बच गया इधर हो गया। मान लो यहाँ पर 0 होता, यहाँ पर 200 होता, और यहाँ कितना बचा? 19,800 में से और 18,950 माइनस करोगे तो क्या आएगा? 0, 5 और 950 आएगा क्या? 950 यहाँ आया। मान लो 10 ये सही है, और 190 तो यहाँ आ जाएगा। फिर 190 यहाँ आ गया। बताओ क्या एक्यूरेसी इस मॉडल की ओवरऑल? कोई कैलकुलेट करो यार, जल्दी बताओ। इस एक्यूरेसी है 18,950 प्लस 10 डिवाइड बाई 20,000। बताओ क्या आ रहा है कैलकुलेशन इसका? एनीवन प्लीज डू कैलकुलेट दिस। 94.8. Okay. See, your model is getting 94.8% accuracy. See carefully. Your model is getting 94.8% accuracy. Let's see this data here carefully. फॉर कैंसर पीपुल 200 में से सिर्फ 10 लोगों को बोला है कैंसर है। तुमने 180 लोगों को डिस्टर्ब कर दिया है। और डिस्टर्ब मतलब रियली डिस्टर्ब, मजाक वाला डिस्टर्ब नहीं, एकदम मतलब हो सकता है वो बहुत लोगों को तुम निपटा भी दो इसमें से। आर यू गेटिंग माई पॉइंट और नॉट? है ना? सो योर मॉडल इज सो मच एक्यूरेट, 94% accurate, but yeah, we are getting very less accuracy for cancer, and this is a really a big challenge, really a big challenge. Due to this, maybe problem will occur. So how can we solve this problem? No, there are two method. There are two way we can solve this problem. See carefully. Suppose we got this problem, okay, where like हमने ये प्रॉब्लम हमने देखा जहाँ पे इस तरह की प्रॉब्लम आ गई, मतलब कि एक्यूरेसी हमें नहीं मिल रही है, या फिर इसको बोलते हैं एक्चुअली इम्बैलेंस्ड डेटा. Imbalanced data. So how can we solve this such type of data set? There are two types of there are two way we can do this. First one is called sampling, and another is called like sensitive learning. Sensitive learning. Okay. So we are more like either you can go like this, either we can go like this. Let's talk one by one. Let's first talk what is sampling. Okay, guys, I think this is lunch time now. So let's take first lunch. Okay, when you will come back, we'll start from here. Okay, I think no. Let's first discuss this ना, क्योंकि ये इस लंच के बाद आगे तो कुछ और शुरू करेंगे. इस 15-20 मिनट लगे तो खत्म कर ही देते हैं. ठीक है, ऑल ऑफ यू ओके ना? एनीवन? ठीक है ना, ठीक है. पहले कंप्लीट कर देते हैं इसको, ज़्यादा टाइम लगेगा. सी, अब लंच टाइम को थोड़ा बढ़ा लेंगे. देखो यहाँ पे, सी, फर्स्ट थिंग इज सैम्पलिंग. देखो सैम्पलिंग मीन्स व्हाट. देखो अभी क्या था, मान लो हमारे पास, मान लो 1000 डेटा होता, उसमें से 900 लोग नो फ्रॉड होते हैं और 100 लोग फ्रॉड होते हैं. तो हम क्या करते हैं कि आइदर वी कैन इंक्रीज दिस डेटा टू 900. सो फिर मेरा डेटा क्या हो जाएगा, 900 और 900 हो जाएगा. तो ये अब बैलेंस डेटा हो गया, सिंपली ट्रेनिंग कर सकते हैं. दिस इज कॉल्ड सैम्पलिंग. दूसरा तरीका या तो सैम्पलिंग का ही 900 को 100 कर देते, फिर 100 हो जाते, फिर ऐसे भी कर सकते हैं. तो ये प्रोसेस जो 100 को 900 की है, इसको बोलते हैं अप सैम्पलिंग. और ये जो 900 को 100 की है, इसको बोलते हैं डाउन सैम्पलिंग. ओके, अब रह गया सवाल कि अप सैम्पलिंग करेंगे कैसे. तो ये आप बोल रहे हो कि ये मेरा अप सैम्पलिंग है, तो ये अप सैम्पलिंग होगा कैसे, ये बहुत इंपॉर्टेंट बात है. देखो एक होता है तरीका, उसको बोलते हैं रैंडम सैम्पलिंग. हम क्या करेंगे, 100 डेटा है, 100 में से रेंडमली कोई पकड़ेंगे उसमें ऐड कर देंगे, रेंडमली कोई पकड़ेंगे उसको ऐड करते जाएंगे, रेंडमली उठाओ डालते जाओ. कुछ उसके अंदर हो सकता है. इस तरह से करने से क्या होगा कि बहुत सारे डेटा जो होंगे वो आपके रिपीटेड हो जाएंगे. बट एनी वे विल डू दिस, वी ट्राई टू डू दिस, दैट्स व्हाई वी आर डूइंग दिस. सो ऐसे ऐसे करते जाएंगे, ऐड करते जाएंगे. ऐसे करने से क्या होगा, हम 100 को 900 में कन्वर्ट कर देंगे. बहुत इजी टास्क नहीं होता है करना, बट ऐसे करने से कई बार डेटा में रिडेंसी भी आती है. बट ये जनरल तरीका है करने का. आप सैम्पलिंग, डाउन सैम्पलिंग बहुत सिंपल है. रेंडमली 900 में से 800 डिलीट कर दो, रेंडमली कोई सा भी 800, 100 बराबर हो जाएगा. बट ये मेथड वर्क करेगा नहीं बहुत हद तक. इसीलिए सैम्पलिंग का एक बहुत अनदर मेथड है. और तुम्हें जान के बहुत खुशी हुई कि ये जो मेथड है वो किसने बनाया है, वो इंडियंस ने बनाया है. ठीक है, इंडियन एक स्टूडेंट पीएचडी स्कॉलर का रिसर्च पेपर है, और बहुत ही फेमस हो गया है इंडस्ट्री में वो. और वो जो रिसर्च पेपर जिसका है वो भी अरबपति बनी गया है. बहुत लोगों ने उसे मतलब खरीद लिया है बहुत लोगों ने. देखो ये सी क्या है, एक मेथड है, उसको बोलते हैं स्टेम, नॉट स्टेम, क्या बोलते हैं उसको, स्टोम बोलते हैं शायद. S-T-O-O, smooth, not stem, smooth. S-M-O, yes, this one, smooth. स्मूथ बोलता है नॉट स्टेम। देखो मैंने कैसे जाऊंगा, मैं उसके ना फुल फॉर्म को पढ़ने लग जाऊँ मैं। देखो इसको बोलते हैं सिंथेटिक माइनॉरिटी ओवर सैम्पलिंग टेक्निक। इसका फुल फॉर्म है सिंथेटिक माइनॉरिटी ओवर सैम्पलिंग टेक्निक। ये एक इंडियन रिसर्चर का पेपर था और बहुत ही फेमस है। वो क्या बोलता है कि जो माइनॉरिटी आपके पास है, जैसे 100 था, आप 100 डेटा को पॉइंट्स रख लो, ऐसे 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 ऐसे, जो भी डेटा है 100 का। अब ना इस आपस में तीन को कनेक्ट करो, इस मान लो ये तीन को कनेक्ट किया और इसका एवरेज ले लो, मान लो ये पॉइंट हो गया, इसको ऐड कर दो और यही लेबल दे दो। फिर तीन को पकड़ो, ये ऐड कर दो, इसी को लेबल दे दो। ऐसे करके ये इंप्रूव करता है। तो एक्चुअली के एन एन होता है, के नियरेस्ट नेबर, इसी पे ये वर्क करता है, के एन एन पे। तो ये एक तरीका है इस मोड। जनरली जब भी हम सैम्पलिंग करते हैं ना, तो हम इस मोड को ही यूज करते हैं। whenever we are doing sampling, डेटा को इंक्रीज करने के लिए, दैट टाइम वी विल यूज स्मूथ। क्या सैम्पलिंग क्लियर है सभी को? यस यस। स्मूथ एक्सप्लेन करूं कि पूरा सैम्पलिंग? स्मूथ, तो कोई स्मूथ कुछ ज़्यादा है नहीं, मतलब इतना बस उसका है आइडिया, ये बेटर बात है। बट आइडिया मिलने वाला लगता है कितना आसान काम है, उसने अब सोचा। ये देखो स्मूथ है, फुल फॉर्म होता है सिंथेटिक माइनॉरिटी ओवर सैम्पलिंग टेक्निक। ये क्या बोलता है कि जो तुम्हारे पास माइनॉरिटी डेटा है, मान लो तुम्हारे पास 100 लोग हैं जो कैंसर वाले हैं, उन डेटा को प्लॉट करो यहाँ पे। मान लो 2D 3D जितने में होता, हम लिखते चले जाते हैं ऐसे करके। तो इसको एक्सेस पे प्लॉट कर दो। अब डेटा ऐसे कहीं ना ऐसे ही प्लॉट होगा पूरा। अब वो कहता है के एन यूज करो, के नियरेस्ट नेबर। और तुमने इसका पकड़ा, इसका नेबर लो, ये लिया, और इसका नेबर मान लो एक और ये हो गया। तो इन दोनों तीनों का मिडिल ले लो, जो पॉइंट हुआ उसको डाल दो इस पॉइंट में। तो मान लो इन तीनों का मिडिल एक पॉइंट आ गया। अब इसका मतलब 100 से अब 101 पॉइंट हो गया, और इसको भी कैंसर का पेशेंट ही बोलेंगे। गॉट इट और नॉट? फिर टेक कोई तीन रेंडमली, फिर उसका भी कोई पॉइंट लो, इसको भी ऐड कर दो यहाँ पे, तो 102 हो गया, डेटा हो गया, क्योंकि ये भी एक डेटा आ गया। आप और इसको भी लेबल कर दो कैंसर से। गॉट इट और नॉट? क्लियर all of you? So this is a sampling technique, very helpful, very helpful to handle the imbalanced data. Okay. Anyway, let me delete this. Now go for the your sensitive learning. We discuss those as well. That is sensitive learning. Sensitive learning क्या बोलता है कि देखो, you already have your imbalanced data. Take it like maybe हमारे पास 900 नो फ्रॉड होता है और 100 फ्रॉड होते हैं। सो सेंसिटिव लर्निंग इज सेइंग कि इसको सैम्पलिंग मत करो, जितना डेटा है उतनी की ही ट्रेनिंग करो। बट ट्रेनिंग करते समय मॉडल को ये अपडेट करो कि आपका फोकस किधर है लर्निंग पे। सपोज यू आर सेइंग कि मैं बोलता हूँ W1 में भी एक में भी लिखता हूँ A1। सपोज दिस इज माइनर मेजॉरिटी ना, आई एम सेइंग 0 और कॉमा A1, और मैं इसको कहता हूँ 10% दो और 90% इसको दो। तो अब क्या हुआ कि वो अपने ट्रेनिंग करते समय मॉडल जो होगा वो मोस्टली फोकस होगा 1 पे, मतलब माइनॉरिटी पे। इसको देगा थोड़ा भी गलती ना हो, इधर अगर गलती हो तो चलेगा, बट इधर गलती नहीं होना चाहिए। दिस इज कॉल्ड सेंसिटिव लर्निंग। वेरी इंपॉर्टेंट। वी विल सी कि हम कैसे इम्प्लीमेंट करेंगे इसको, बट इसकी ट्रेनिंग बहुत शानदार है। When we are doing the training, we try to focus on only particular class, not each class. But basically इसका मतलब क्या हुआ? You are not going to train with uniform distribution. Do you know what is uniform distribution? This is a uniform distribution. Now, whenever your fx is any fixed number, this is a uniform distribution. And if you do the integration of all, like if you do the, sorry, if you are going to do like this integration fx dx, you will get 1. पता है ना आपको? How many of you already know what is uniform distribution? Actually statistic आपके syllabus में है. That's why I want to know, क्योंकि मुझे आइडिया लग जाए मुझे कितना बीनो जाकर पढ़ाना होगा. जानते हो आप लोग? अच्छा ठीक है. कितने लोग जानते हो व्हाट इज नॉर्मल डिस्ट्रीब्यूशन? दैट इज आल्सो इन आवर सिलेबस. ओके, सो मुझे बिल्कुल जाना पड़ेगा नीचे. हाउ मच ऑफ यू ऑलरेडी नो व्हाट इज गॉसियन डिस्ट्रीब्यूशन? आई थिंक यू गाइस नो दिस, क्योंकि ये तो आप लोगों ने पढ़ा होगा स्टैटिस्टिक में या फिर क्वेश्चन इंजीनियरिंग मैथमेटिक्स में कभी ना कभी पढ़ा होगा इसको. ऐसा कुछ होता है. अभी मैं फिगर बना रहा हूँ, आप लोगों को ध्यान आ जाएगा. ग्राफ कोई पढ़ा है? पढ़ा हो. और इसका फॉर्मूला ऐसे होता है 1/2 पाई सिग्मा स्क्वायर ई टू दी पावर एक्स माइनस म्यू होल. हाँ, दिस इज कॉल्ड नॉर्मल डिस्ट्रीब्यूशन, ऑल्सो गॉसियन डिस्ट्रीब्यूशन. एक ही चीज़ है. नॉर्मल डिस्ट्रीब्यूशन एक्चुअली बोलते हैं ना, क्योंकि दुनिया का हर डिस्ट्रीब्यूशन फॉलो, लाइक मोस्ट ऑफ द टाइम डिस्ट्रीब्यूशन फॉलो द नॉर्मल डिस्ट्रीब्यूशन. इसलिए इसको बोलते हैं नॉर्मल गॉसियन डिस्ट्रीब्यूशन. इसलिए इसको बोलते हैं कि नॉर्मल डिस्ट्रीब्यूशन, क्योंकि नॉर्मली हम यही मिलेगा आपको. जैसे अभी अगर तुम कोविड का डेथ देखो, उसका प्लॉट देखोगे ऐसे मिलेगा. कोविड का मतलब केसेस देखोगे तो ऐसे मिलेगा, है ना. सो ऑलवेज देयर इज अ पीक एंड देन there is a like positive slope and negative slope always there. So this is called basically normal distribution. Still it's called a Gaussian distribution. ये इसका इक्वेशन होता है. if we find, अच्छा कोई बताएगा इसका एरिया कितना होगा? यहाँ से लेके पूरा अगर एरिया निकाले तो इसका एरिया कितना होगा? किसी को याद है टोटल एरिया कितना होता है इसका? एनी वन ऑफ यू कैन लेट मी नो व्हाट इज द एरिया ऑफ दिस. किसी को याद है? सच में याद नहीं किसी को? मजाक कर रहे हो? तुम लोग बताने के मूड में नहीं हो ऐसा? बहुत आसान है भाई. एनी वन सौ तनिष्क बताओ क्या होगा इसके एरिया? तो याद नहीं. कोई और बताओ यार. याद नहीं है? सोचो, सोच के बताओ. 1 मिनट लो, सोच के बताओ यार. क्योंकि सबको पता है, आप लोगों को सबको पता है. इट्स नॉट पॉसिबल कि पता नहीं हो सकता. आई एम नॉट एबल टू बिलीव दिस, आपको पता नहीं हो सकता. मैं कह रहा हूँ, मैं 40 लोग जो देख रहे हैं ना, सबको पता है ये. और बस एक बार अपने ब्रेन पे जोर लगाओ, पता चल जाएगा क्या है इसका एरिया. कोई ऐसा नहीं जिसको पता नहीं होगा. एक बार सोचो जरा. शिवम बताओ यार. आर्यमान बताएगा. आर्यमान त्यागी बताओ. आर्यमान त्यागी, आई कांट बिलीव कि तुम नहीं बताओगे. अच्छा चलो कोई नहीं. एक वो गर्ल है यार, तेज, क्या नाम है उसका? हम्म, मेघना बताओ क्या है? याद नहीं है? अरे यार, 1 होगी ना. अरे ये पीडीएफ है ना, प्रोबेबिलिटी डेंसिटी फंक्शन. एनी प्रोबेबिलिटी डेंसिटी फंक्शन की प्रोबेबिलिटी पूरा ग्राफ एक होगा. एक से अधिक प्रोबेबिलिटी होता है किसी का? हाँ हाँ, तो 1 ही होगा ना. इसलिए तो बार बार जोर दे रहा था, कोई तो बोल दो 1, कोई तो बोल दो 1. अरे यार एकदम, मैं इसलिए जोर दे रहा था खूब कि कोई बोले 1. देखो, कोई भी प्रोबेबिलिटी, कोई भी डिस्ट्रीब्यूशन फंक्शन हो, अगर एक्सपोनेंशियल होगा लाइक लेमडा ई टू द पावर माइनस लेमडा एक्स, अगर तो माइनस इन्फिनिटी से लेके इन्फिनिटी तक इसका अगर एरिया निकालोगे तो यू विल गेट वन। सेम विथ नॉर्मल डिस्ट्रीब्यूशन, 2 पाई सिग्मा स्क्वायर ई टू द पावर एक्स माइनस म्यू होल स्क्वायर डिवाइड बाई 2 सिग्मा स्क्वायर डी एक्स, विल गेट वन। किसी का भी मान लो, अगर तुम्हारे पास एफ एक्स वो है के डी एक्स, मतलब कि यूनिफॉर्म डिस्ट्रीब्यूशन, गेट वन। सो एनी फंक्शन, if it is a probability density function pdf, you'll get always the no integration will 1, clear or not? दैट इज ऑन आवर सिलेबस है ना। मैं ऐसे मतलब ये सब हमको पढ़ना है, स्टैटिस्टिक है हमारे सिलेबस में। सो इफ यू वांट टू लर्न स्टैटिस्टिक यू हैव टू नो द प्रोबेबिलिटी डेंसिटी फंक्शन, प्रोबेबिलिटी डिस्ट्रीब्यूशन फंक्शन। सो बेसिकली व्हेन आई विल स्टार्ट दिस, आई विल स्टार्ट जनरली फ्रॉम वेरी बेसिक, मतलब मैं आइडिया लेता है कि मुझे कहाँ से स्टार्ट करना है। तो आई विल स्टार्ट फ्रॉम प्रोबेबिलिटी, कि प्रोबेबिलिटी होता क्या है थोड़ा बहुत, उसके बाद इसके तीन वर्टिकल, डिपेंडेंट प्रोबेबिलिटी, इंडिपेंडेंट प्रोबेबिलिटी, और क्या होता है तीसरा, कंडीशनल प्रोबेबिलिटी ना। इंडिपेंडेंट, इंडिपेंडेंट और सॉरी नॉट कंडीशनल, डिपेंडेंट तो कंडीशनल हो गया, एक्सक्लूसिव प्रोबेबिलिटी है ना। सो आई विल स्टार्ट फ्रॉम हियर एकदम वेरी बेसिक, उसके बाद फिर प्रोबेबिलिटी डेंसिटी फंक्शन, फिर स्टैटिस्टिक, ठीक है। तो एकदम स्लो, एकदम माइनस से लेके चलूँगा, बिकॉज मैंने वही आइडिया ले रहा था कि कहाँ से मैं शुरू कर सकता हूँ, ठीक है। डोंट वरी। सो आफ्टर द न्यूरल नेटवर्क विल स्टार्ट द स्टार्ट्स, फर्स्ट विल कंप्लीट द न्यूरल नेटवर्क। अच्छा ठीक है। तो कोई लोग बताओ जिसको किसी को कहीं भी डाउट हो, कहाँ से स्टार्ट करके, शुरू से स्टार्ट करके, लाइक हमने अभी न्यूरल नेटवर्क बिल्ड किया, एक रिग्रेशन का बिल्ड किया, एक क्लासिफिकेशन आप लोगों ने किया, मैंने आप लोगों से करवाया, फिर हमने एक देखा कि स्क्रैच से हम कैसे बना सकते हैं न्यूरल नेटवर्क, हमने वो बनाया स्क्रैच से। तो हमने स्क्रैच से बना लिया, उसके बाद हमने शुरू किया फिर क्या। हाँ हाँ बिल्कुल, वाई नॉट, लेट मी शेयर दिस जस्ट अ मिनट। फाइनली व्हाट, ओके गाइज। सो आई शेयर्ड है ना, जो जो भी मांग रहे थे मैंने शेयर कर दिया स्लैक में, आप देख लीजिए, ठीक है। ओके, हाँ ठीक है। सो लेट्स गो फॉर लंच ब्रेक, दिस इज 150, सो वी विल मीट ऑन 250, करेक्ट। 250 मतलब लाइक ऑलमोस्ट 3 p.m. ओके, सो वी विल मीट ऑन दिस टाइम, ओके। प्लीज कम ऑल ऑफ यू, ओके। थैंक यू टू ऑल ऑफ यू, थैंक यू वेरी मच। हेलो, 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 या ऑडिबल ना, ओके लेट्स स्टार्ट दिस, ठीक है, आगे बढ़ते हैं। सो ओके, so let's go into more in this. So see, till now we see, suppose our data is imbalanced. So how can we handle? These are two things we can do. Either we can do sampling and try to balance the data. Otherwise, generally we can apply sensitive learning. So both way we can handle those concepts for a imbalanced. But suppose you are working on an image data, okay, and suppose your model will imbalance when you are working for a cat and dog. So here generally we don't apply, like sensitive learning, because Both are important, either cat or dog. But suppose in data we have 900 cat and 100 dog, so we can't apply sensitive learning here, because we can't say dog is more sensitive than cat. Both are equally important, because we try to predict whether it's a dog or cat. So now the question is, how can we build the model? So definitely here we have to do sampling. So think the simple data, like you're working on maybe sales data or any data, like till now we work on data. So on data it's easy to either use smart or any maybe upsampling or downsampling. But for images it's really tough, no? So how can we do this? Well, there is a very popular approach nowadays we are using in industry. Suppose we have 10, I want to make it 90. So there is a network called GAN, GEN network. Do you know this? What network is? It's called generating model. See, nowadays we can generate images, okay, and nobody will able to identify whether those images are true or maybe, like, it's not a real image. Very difficult. Nobody can decide. Nobody can generally answer whether it's a real or fake image. So we can generate images. So we can build a GAN model, gen model, and using GAN model we can generate this 90 dog. So make a, sorry, we have 100 now, so you can make a generate 800 more using this network, and this become 900. So this is the for GAN network. But the problem is, GAN is not in your syllabus. There are some reason behind it why it's not syllabus. Your syllabus for CNN RNN only for the fundamental, not a deeper part. So if you want to learn GAN first, you have to so why I'm saying GAN, sometimes people say GAN. So if you want to learn GAN, you have to first learn deeper and deeper for CNN, RNN, and RCNN. So if you are okay with CNN, RCNN, RCNN both combined, then you are able to understand how GAN will work. But generally, like here in your syllabus, only we have CNN, RNN. Even we don't have the RCNN network. That's why we don't go for GAN. Okay. Anyway, so I'm just trying to explain you. Suppose if conditions like this, how can you handle it? Now let's come again to the imbalanced data. Let's go again for your confusion matrix. So this is your confusion matrix, and confusion matrix we have like this is true negative, this is false positive, true positive, and false negative. This is 0, this is 1, this is 0, and this is 1. These are true value, and these are prediction. Okay. See here I will must tell you two formula that is really important. One is called recall, and another is called precision. Recall means true positive divide by true positive plus false negative. Precision means true positive divide by true positive plus false positive. So these two formulas, see carefully, recall and precision. So both are very important. Sometimes maybe you are more focused on recall. Sometimes you are more focused on precision. Okay. And normal accuracy we already saw how can we do this. Let's talk about recall first. Let me write here recall. So still very less people join. Huh? Are you able to see what is like? Are you able to see the formula of recall and precision? Okay, guys. No, I just talked to. See this, guys. So just see the recall formula. Recall is saying true positive divide by true positive plus false negative. See carefully. Let me write this formula here. Recall is equal to true positive divided by true positive plus false negative. See, if I increase the recall, definitely my false negative will decrease. Are you getting my point? So just try to recall the fraud example. In fraud example, you try to reduce the false negative. Correct? Try to recall na false negative. Uh, See, there are two data na fraud, no fraud, no fraud, fraud. So if this see this is false negative na. फ्रॉड को नो फ्रॉड बोल रहा है फ्रॉड इज पॉजिटिव वाई पॉजिटिव बिकॉज दिस विल बी माइनर डेटा हम ऑलवेज माइनॉरिटी के टेक पॉजिटिव एग्जांपल सो हियर दिस फ्रॉड को नो फ्रॉड बोला दिस इज फॉल्स नेगेटिव एंड वी ऑलवेज ट्राई कि ये मत हो है कि नहीं हम शुरू से तो यही चाह रहे हैं ना कि फ्रॉड को वो फ्रॉड प्रोटेक्ट करे फ्रॉड को वो नो फ्रॉड ना करे यस या नो है ना आई थिंक सम ऑफ यू आर नॉट एबल टू आइदर सम ऑफ यू आर स्लीपिंग और समथिंग क्यों भाई है ना लंच करते हैं सो रहे हो ना चलो कोई बात नहीं what is you know this is recall let's talk about precision precision is equal to true positive divided by true positive plus false positive whenever you are looking to decrease false positive sometimes we don't want false positive that time we can use precision so generally sometimes you are focused on recall sometimes you are focused on precision anyone let me know when we are going to apply this recall or precision सभी लोग जरा कोई भी बताए कि हम रिकॉल या प्रेसिजन कब अप्लाई कर सकते हैं एनीवन कब हमें अप्लाई करना चाहिए रिकॉल और प्रेसिजन को बताओ हम्म नहीं ये तो ठीक है ये तो कंसेप्ट हो गया कि तब करेंगे ये सही भी है तुम्हारा फॉल्स नेगेटिव रिकॉल करना चाहिए बट मैं ये नहीं पूछ रहा हूँ मतलब कब हमें इसके बारे में सोचना है कि हम रिकॉल यूज करें या प्रेसिजन यूज करें मतलब ये तो रीजन हो गया कि हम अभी रिकॉल करना चाहिए या प्रेसिजन मैं ये नहीं पूछ रहा हूँ रिकॉल या प्रेसिजन कब हम सोच सकते हैं कि यार अभी हमको नॉर्मल एक्यूरेसी नहीं लगाना पड़ेगा ये एक्यूरेसी लगाना पड़ेगा और यू डोंट प्लीज यू डोंट रिप्लाई ना कोई और बताए रोहित कुमार फॉर गेटिंग अप्रॉक्सीमेट रिजल्ट्स नहीं ऐसा नहीं है when we want positive accuracy so when we want positive accuracy अरे मैं ये नहीं पूछ रहा हूँ अनुभव यू आर राइट बट आई एम नॉट आस्किंग रिकॉल कब और ये कब क्वेश्चन लेट मी फ्रेम अगेन मे बी आई एम नॉट एबल टू फ्रेम द क्वेश्चन लेट मी अगेन आस्क हम कब सोचेंगे कि हमें यार नॉर्मल एक्यूरेसी से काम नहीं चलेगा देखो वेरी गुड कुणाल भारद्वाज देखो ये इसने बताया है व्हेन इम्बैलेंस्ड क्वालिफिकेशन सबसे पहले डेटा तो इम्बैलेंस होना चाहिए ना अल्टी अनलेस यू डोंट हैव इम्बैलेंस डेटा हम इसके बारे में सोचेंगे नहीं बैलेंस डेटा है तो हम डायरेक्टली एक्यूरेसी यूज करेंगे ना फर्स्ट यू हैव टू चेक अवर डेटा whether it's imbalance or not okay then you have to talk recall and precision बट फॉर्चुनेटली क्या है कि रिकॉल और प्रिसीजन जिस तरह के प्रॉब्लम्स के लिए हमें लगाना होता है वो प्रॉब्लम्स हमेशा इम्बैलेंस होते हैं। जैसे कि मेडिकल डेटा ऑलवेज इम्बैलेंस्ड है ना। whenever you will do such type of problem ना, जो जहाँ पे भी ये लगा सकते हैं वहाँ पे डेटा कहीं बैलेंस हो ही नहीं सकता। जैसे फ्रॉड है, अब कितने लोग फ्रॉड हो सकते हैं? 1000 में से 10 लोग, 20 लोग, 50 लोग, इससे तो फ्रॉड हो ही नहीं सकते। और आधा आधा लोग फ्रॉड होने लगे ना तो बैंकिंग सिस्टम चलेगा ही नहीं, है कि नहीं? गॉट द प्रॉब्लम? First of all, your data has to be imbalanced data. If it is imbalanced data, then think कि मेरे लिए क्या needed है. Whether maybe sometimes you need recall, sometimes you need precision, but that totally depends on the data set. Data will allow you कि क्या करना है. Even we will do project, सब कुछ प्रोजेक्ट करेंगे थोड़ा और पढ़ने, तो वहाँ पे हम imbalance का एक मैं आपको एग्जांपल लेकर कराऊंगा पूरा, डोंट बी वरी। ओके, यहाँ तक किसी को दिक्कत है तो बताओ, एनीवन ऑफ यू? नहीं ना? एनीवन जिसको कोई प्रॉब्लम इशू चैलेंज है? हाँ, एक बार बता दो। देखो, सपोज यू हैव अ डेटा ओके फॉर एनी टास्क, और ये आपका टारगेट है। उसके बाद आपको कुछ नहीं करना, सी योर टारगेट, मतलब सपोज इट लुक्स लाइक दिस। आपने इसको देखा, आपने देखा कि यार जीरो कितने बार है? 10 बार जीरो है। वन जो है वो 3 बार है। इसका मतलब अगर इसमें हम 100 से मल्टीप्लाई करें तो 1000 बार जीरो है, और 100 से मल्टीप्लाई करेंगे तो 300 बार वन है। तो ये डेटा है एक्चुअली। अब जब ये डेटा है तो वी केम टू नो कि यार ये तो इम्बैलेंस डेटा है। या तो 600 400 होता, 500 500 होता, या फिर इसको एक और जीरो कर दो, एक और जीरो कर दो, दो केवल वन कर दो। तो दो कर दोगे तो ये हो जाएगा तुम्हारा 1000, और ये हो जाएगा 200, ये हो जाएगा 1200। अब देखो, अब बिल्कुल ही इम्बैलेंस डेटा हो गया। मतलब या तो 500 500 हो, 600 400 भी चलेगा, वो बैलेंस्ड है। बट ये 200 500 बिल्कुल इम्बैलेंस डेटा है। So first you have to see whether it's imbalance or not. If it is imbalance, then see minority. Minority ही always important होगा। Minority को positive बनाइए। Most of the time, whenever you are doing a classification, binary classification problem, industrial data is imbalanced. When it is imbalanced, minority is important. 100%, 99% बोल रहे, 1% का कोई उम्मीद नहीं। 99% टाइम योर माइनॉरिटी विल इम्पोर्टेंट। अगर 1% चांस हुआ कि मेजॉरिटी इंपॉर्टेंट हो गई ना, आपको मॉडल बनाने की जरूरत ही नहीं है। अगर मेजॉरिटी इंपॉर्टेंट हो गई तो आपको मॉडल बनाने की जरूरत ही नहीं है, क्योंकि बाय डिफॉल्ट ही मेजॉरिटी है, एक्यूरेसी मेजॉरिटी की है। तो वो तो आप ऐसे भी बोल दोगे, जैसे मान लो किसी जंगल में दो ही तरह के जानवर हैं, उसमें से 2000 तुम्हारा जो है वो मे बी डॉग है, और केवल 10 कैट है। अब तुम्हें वहां पर एक मॉडल बिल्ड करना है जो मॉडल जानवर देखता है डॉग है कैट है, और तुम्हारा डॉग इंपॉर्टेंट है, तो मॉडल बनाने की जरूरत ही नहीं है, वो तो 99% टाइम डॉग ही होगा, कैट तो केवल 10 है। Are you getting my point? So if you want to make a model for majority, no need to build a model for majority. Always try to build a model for minority. So if now you have to build a model for minority, then you have to check which is important. Positive is important and negative. Just let me show you. Now let's talk about the same fraud example. अब फ्रॉड में है, फ्रॉड को नो फ्रॉड बताना या नो फ्रॉड को फ्रॉड बताना, क्या ज्यादा खराब है? व्हाट इज फर्स्ट वन? नो फ्रॉड। इसका मतलब दिस इज व्हाट, दिस इज ट्रू नेगेटिव या फॉल्स नेगेटिव या फॉल्स पॉजिटिव या ट्रू पॉजिटिव, ये क्या है? क्या है ये? फॉल्स निगेटिव। देखो ध्यान से, एक्चुअली ना ज़्यादा टेंस लेने की जरूरत नहीं है, जरा सोचो। फ्रॉड और नो फ्रॉड में मेजॉरिटी तो नो फ्रॉड ही होगी ना, फ्रॉड तो माइनॉरिटी होगी। तो इसको पॉजिटिव बोलेंगे, वन बोलेंगे, और नो फ्रॉड को जीरो बोल देंगे, तो निगेटिव बोल देंगे। तो इसका मतलब ये जो आ रहा है नो फ्रॉड तो निगेटिव है, क्योंकि पॉजिटिव है तो निगेटिव है, लेकिन ये सही नहीं है। इसका मतलब है फॉल्स निगेटिव है, और वी वांट टू डिक्रीज दिस। हम कभी ये चाहते ही नहीं कि ऐसा हो, हम कभी नहीं चाहते कि फॉल्स निगेटिव आए। तो फॉल्स निगेटिव को करना है अगर रिड्यूस, मैं पता है रिकॉल फॉर्मूला में आता है true positive divided by true positive plus false negative. So we will generally decrease this false negative. So if you want to decrease this, automatically recall will what? Increase. So when we will do training, we will more focus on recall. So if we more focus on recall, automatically false negative will decrease. क्योंकि हम लोग इसको इंक्रीज करेंगे। इसको इंक्रीज करने का मतलब ये होता है कि आपको इसको डिक्रीज करना है। इससे बहुत इम्पैक्ट पड़ेगा नहीं इसको बढ़ाने से, है कि नहीं? आपको इसको डिक्रीज करना है। Clear? Now is it clear to all of you? Anyone who have any doubt, please let me know. Okay. So now I'm giving another example. You have to build your matrix. You have to calculate the overall accuracy. You have to calculate the recall and precision all. So I'm making like horizontal. Okay. So this is horizontal. I'm making like this. See carefully. This is Y, and this is prediction. Okay, you have to build everything. So I'm writing here like, so confusion मैट्रिक्स बनाइए, CM एक्यूरेसी कैलकुलेट कीजिए, ओवरऑल प्रेसिजन कैलकुलेट कीजिए, रिकॉल कैलकुलेट कीजिए। करिए सभी लोग, प्लीज डू दिस ऑल ऑफ यू। Done. Very good. Very good. All of you done. All done. See, it's very simple, guys. I think you guys are done now. That's anyone? Is you doubt है क्या इसमें? Just let me know whether I have to do this or not. Done na? Very good. Actually, very simple na. Just we have to do this. Now, let's just a minute. एक second ना. Ah, done guys. So see, it's very simple actually. If you want to calculate the just what have to do, you have to count first two negative. देखो एक, दो, then तीन, चार, पाँच, छः, बस सिक्स आई थिंक है ना. फॉल्स नेगेटिव, फॉल्स नेगेटिव. दिस वन द फॉल्स नेगेटिव. एक, दो, तीन, चार, पाँच, छ and 7. This is so this is false negative, है ना. Now see the true positive. So false positive एक, false positive दो, false positive तीन, चार, पाँच, छः, सात, बिल्कुल 8 false positive. What is true positive? So true positive is this one. दो एक तीन, तीन दो पाँच, पाँच है बस. True positive is only 5, huh? Okay. So now this is very simple. Now accuracy. Accuracy is what? 7, 6 plus 7 is 11. 11 and 8 and 7, 26. What is precision? Precision is true positive. True positive is 5. 5 divided by 5 plus false negative. Precision, no, precision is equal to false positive. So 8. So 5 divided by 0. This is precision. What is recall? Recall is equal to true positive is 5. 5 plus what? 7. 7 5 12. This is recall. So this is precision, this is recall. Everything we calculate in a way. But I'm just trying to explain you. That's why I'm doing equation and each everything. When we are going to apply this, no, directly we have a API. Just we have to call this. It will return us everything. Okay. So but अभी उसके लिए time लगेगा. We have to go for that. But just theoretically I cover everything for a need to check accuracy of your classification problem, because now we are going to deeper into classification problem, because now we will go for image problem. How can we classify our images? How can find whether it's a cat or dog? So that's why before going to those complex topics, first I try to complete the checking of your accuracy. How can we check your model is whether accurate or not? That's why I'm trying to find these things. This is really really important. Now we will move to another particular domain. Okay, so let me go here. Sorry. Now let's go here. So basically, we have this fully connected neural network, and this fully, sorry, see, we have this neural network. So in this neural network, we have a different vertical. So till now we work only on fully connected neural network. Now let's go for CNN, and after that we will go for RNN. So let me try to first build a story for CNN, and then we'll go for RNN. Okay. So see this. Suppose you want to work on an image. Okay. Suppose this is a cat. ओके, मे बी एक कैट के हमारे पास 1000 इमेज है, और एक कैट एक मतलब 1000 इमेज है कैट के. सपोज वी रीड दिस इमेज. आपको पता है जब आप इमेज रीड करते हो किसी को भी तो वो पिक्सल्स होते हैं, करेक्ट है ना. दैट पिक्सल्स कम्स इनटू द मैट्रिक्स फॉर्मेट. सो ये आएगा, मान लो हो गया 200 मल्टीप्लाई 200, मतलब 200 विथ 200 हाइट. ओके. और और मल्टीप्लाई एक 3 आएगा. 3 एक्चुअली क्यों आता है? कलर्ड इमेज के लिए. डू यू नो कलर्ड मीन्स RGB? पता होगा ना इतना तो. कलर्ड मीन्स RGB. सो दिस 3 comes for the channel. R channel, G channel, B channel. So this 3 is the RGB, 200 width and 200 height. This is the shape of one image. Like this we have total 1000 image. Or this. So this is the total data set. Data set. Now see carefully. Is a total data set. So one data. Let's talk about only one data. One cat. One cat is like this. 2000 width, 2000 height, 3 channel. Just see how much in data in this particular one data. Multiply 12 0 0 0 0. 1,20,000. Yes or not? This is 1,20,000. Okay. See, this is 1,20,000 data in one image. So it means we have total 10,000 image. So 10,000 row, 10,000 row, sorry, 1,000 row, 1,000 data, not 1,000 row. And how much column here? Here, 12 lakh column. No, 1,20,000 column here. 1,20,000 column. It means how much feature we have? Total feature is 1,20,000. Remember, just try to recall it. I think definitely I informed you in yesterday in previous class that if you have n feature, maximum you can use 2 to the power n neurons. Are you able to recall it, guys? Are you able to recall this? So just try to recall it. I told you if n features we need 2 to the power n, but generally what we try to do, we try to use less. But less doesn't mean very less. We are not going to use 2 to the power n, but using less, little less, or maybe half of that. Not going to take less than half of that. Okay, otherwise our model will never work. So see here now, just see here. If you take half, how much you take? Just take 2 to the power 1,20,000. If you do half of this, it will become 2 to the power 1 lakh. I think like this. Just see how much neurons it needed. Just see carefully. See the number, how much neuron it's needed. You know, so such a high number of neurons we needed. Can we are able to build such bigger neural network? We can build, but the problem is where we will train it, on which machine. Even on cloud, we are not able to see. Cloud is, it's not a free service; it's a paid service. If you are going to use cloud, it will take lots of days, and cloud charges increase, just like exponentially. So who will pay for that? The company is not ready to pay for that, because suppose the company have one problem, and the whole problem budget of the problem is X. You are saying to just train this model, budget is Y, and your Y is greater than X. Company say don't use this. I'm ready to go for this problem. Why? Because your solution is more cost, take more cost than problem. So how can anyone going to take your solution? Okay, so that's why this is the problem with fully connected neural network. Okay, that's why whenever image comes, video comes, we don't go for fully connected neural network. We go for CNN. That is called convolutional neural network. And why, how it will solve this problem, because here we are going to share the weights. In CNN we are going to share the weights, but here in fully connected neural network, for each data we have a different weights. Like if you have three feature, let's see, if we have three feature f1, f2, f3, and two neuron, all neuron connected for all feature. But in CNN we are not going to do like this. We'll do with something different. Maybe we have four feature f1, f2, f3, f4. So two neuron, two like this, maybe like this. So we're going to share the weights in convolutional neural network, and that's why it's really very helpful to solving our this specific problem with fully connected neural network. Okay, got it or not? Clear all of you or not? Why we are going for CNN? Say yes or no. Okay, so now, yeah, so now we are going to learn such a very important topic, and that is totally a different network architecture. So see, there are some prerequisite. What is that? We have to know first how can read the images. So don't worry about that, I will explain. Okay, but this network is totally a different architecture network. You can't compare with fully connected neural network, because the architecture of network is totally different. Here architecture of the network is different. Surely we will get little less accuracy if we compare with fully connected neural network. But the problem is, if you want to make a fully connected neural network for images, well, you will never able to build it, because such a high number of neurons, such a high number of layers. Who will going to build it? Where you going to build it? How you will train? Until unless वो एक नया कंप्यूटर आ रहा है ना, क्या बोल रहे हैं उसको, एक नई टेक्नोलॉजी आ रही है, जो क्या बोल रहे हैं, आ रही है ना नई टेक्नोलॉजी वो करने के लिए, कंप्यूटिंग में क्या बोल रहे हैं, अरे यार, just forgetting that. Sorry, quantum computing. Yeah. So maybe sometimes in future quantum computing will be there. So maybe you are able to train that, है ना? क्योंकि वहाँ पे ट्रेनिंग पॉसिबल हो पाएगी. If you guys are know the little bit about quantum computing, वहाँ पता है ना कि वो बढ़ जाता है, एक कैपेसिटी बढ़ रही है, वो भी एक्सपोनेंशियली बढ़ती है ना, जैसे रिक्वायरमेंट बढ़ता है. तो quantum computing maybe someday in future will come. So if that come, so maybe that time we are able to run this. But now we are not able to run this. हाँ, आइदर इफ यू से कि हमारे पास सुपर कंप्यूटर हम ट्रेन करें तो बात अलग है ना. Anyway, so got the problem. So we are going to use CNN. Okay, CNN has a very separate architecture. Let me give you a little bit example. See, CNN means convolutional neural network. Okay, the full form of CNN is, the full form of CNN is convolutional neural network. Convolutional neural network. See, basically convolutional means, there is a term in math called convolution. Just let me know, let me explain you what is convolution. If you have two signal like this and this, so what is convolution means? Just try to pass this signal from this signal. Just you put it here and slide your signal on this. Okay. So when you start sliding, you try to multiply the area of that. Just try to calculate the area. Just see carefully. Suppose you have a, maybe you have a this and this. Okay, and maybe this is 0, this is 0, this is minus 2, this is 2, this is minus 2 and 2. Okay, you just put it here. So if you put it here, this is the length is 4 now, so minus 2 means minus 6. Okay, so before starting convolution is 0. When you start increasing this, suppose you reached here, suppose you reached here, So what happened? This become minus 4 because it's to 0. And if you calculate the area, you'll find this area. Suppose height is maybe 1. So this is 0, 2. So you'll get 2 here. Then again move. So like what happened? The area will start increasing, 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 increasing. Sometimes what happen? Your sliding reach here till एकदम just copy कर लेगा पूरा. That time you'll get the maximum because now if you again you start like this. So now you start the area decreasing just like this. Sorry, not this. This. So this is the convolution basically in math. You either you come across math or maybe if you read the, I don't know whether that is in your curriculum or not. It's called signal and system. If you went through that, definitely you covered the part. So convolution. Even in math also that is there. So concept are almost same in here in computer vision with a little different. Almost same, just little different. So I will explain you everything. Okay. So we will do that tomorrow because this is totally a new topic. So tomorrow we will start with CNN, okay, and then we will. We will not. It's not possible to complete tomorrow itself, but that is a really important topic. To all of you, please come with with an energetic mood because it's a really important topic and very very maybe you guys can use, but the problem with the syllabus is has some limitation, but still I will try to explain you in different dimension of the CNN. Okay, so okay, let's first let me ask one question. If anyone has any doubt from the first class, you can ask from the like the first Python class. You have doubt anywhere till today, just ask. I'll try to explain you. Anyone facing any problem anywhere? Okay. सो गाइस एक बात बताओ, तुम लोग दो दो चीज पढ़ रहे होगे एक साथ? मैं ये भी पढ़ रहे हैं और एग्जाम के लिए पढ़ रहे होगे। एग्जाम तो अब आ गया तो अब तो पढ़ ही रहे होगे, क्योंकि सेमेस्टर तो पूरा पढ़े नहीं होगे। ओह सॉरी सॉरी सॉरी, तो मैं भी सोच रहा था थोड़ी देर पहले। तुम लोग तो अभी नेक्स्ट वीक एग्जाम है, मंडे से स्टार्ट है एग्जाम मेघना, सॉरी या मेघना यस। अच्छा, सो यू गाइस आर हाँ ठीक है, ओके एनीवे, तो सो यू गाइस गेटिंग सैलरी आल्सो ना? स्टिपेंड तो आ रहा होगा आप लोगों को ना अभी, सैलरी कुछ? हाँ ठीक, चलो तो थोड़ी दो सप्ताह मेहनत कर लो, कोई नहीं, चलो वेरी गुड। हाँ बोलो। सॉरी 6 to 10? टुमारो मॉर्निंग, no problem no. So okay, so you guys are not in college, okay, only you no, not all of you no, only you no. Okay, 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 no problem. Okay. Many will, why many will? Okay, 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 okay. So let's do one thing. Tomorrow we will start at 11 a.m. Is it okay? Okay, no problem. So we can do like this. We can tomorrow we will start at 11 a.m. No problem. No, I will manage the syllabus. Okay, don't worry. I will, if times needed. No, sometimes even we will increase this ending time if that will need it. But I think it will not need it. I will complete within the given time. So don't worry. Okay. People will travel. So different days. So but tomorrow some of you are traveling, na? Tomorrow only one person. How many of you are traveling? Only one person. What she said? She said different days. Okay. So for tomorrow, how many of you traveling? Just write yes. At least I will have data. No. If more than 2 3 people, then we will start 11 a.m. But if only one person, so we can start at 10:30. Who is traveling? Oh, Arman is traveling. Okay, so I already like no, no, anyone else? दो लोग और अच्छा, इस वीक में ही अलग अलग दिन ट्रेवल करना है, तो कोई एक दिन फिक्स करोगे तो उस दिन थोड़ा लेट। ओके, अगर थोड़ा एक दिन करोगे थोड़ा लेट कर सकते, चलो कल एक काम करते हैं, कल 10:30 भी स्टार्ट कर लेंगे। सो आर मैन 10:30 तक यू विल रीच देयर। ठीक है, तो 10:30 लेट्स डू ऑन 10:30। लेट्स डू ऑन 10:30। ओके, चलो चलो गाइस, so tomorrow we'll start our session at 10:30. Okay, चलो, thank you to all of you, thank you very much, thank you to all of you। रिकॉर्डिंग सबको मिल रही है ना, रिकॉर्डिंग यू गॉट ना? हाँ ठीक है, थैंक, ओके ओके, थैंक यू टू ऑल ऑफ यू, थैंक यू वेरी मच।